From Mr. Sensibles. I'm just waiting for I don't know what. It was meant to be some other people in here. He says there's quite a few people normally in here. There isn't. But anyway, going live, chatting with Mr. Sensible in a bit about level. I'm not used to talking to myself. He's going to move me into the other room in a bit. I'll just disappear into the other room.
Hello, Bev. Try thinking. Good evening to you.
Good evening.
Hello, hello, and I hope everyone can hear you. Just say something else so I can check the voice levels.
Yeah, hello. How's that
looks
working?
Good. Yeah, it looks good to me. The stream usually has about a 30-second delay from us talking, so
Okay.
just be aware if you're watching. Right. What I'll do is I'll introduce you first. Bev is someone I came across. I had heard the name Bev, but I first came across you. What was it? 2 days ago, Bev, on Emma UK's Discord, I think it was.
Oh well, yeah.
And yeah, was it yesterday or the day before? I'm not sure.
Yesterday,
We were having
I
a
think
nice.
it was.
Was yesterday?
Yeah.
Okay. We had a nice chat. There was Bev and a few others, and Bev is. Now, don't tell me if I'm wrong. You're not a flat earther. You're a leveler. Is that what you called yourself?
Yeah, just
Is that what you called?
just realists. That's all we are.
Well, because I said, let's go on here. I'll give you a good chance to explain your position, and I understand you've got some form of test which you're thinking of doing or planning on doing, and you can tell us about that, and we'll take it from there.
Fair enough.
Okay, so tell us about level.
Oh well. First of all, we don't class ourselves as flat earthers, or I don't class myself as a flat earther because there's obviously topography. So the Earth, being the land, has the topography. So it cannot be flat, and it obviously isn't flat. So to say that the Earth is flat would just be it wouldn't make sense. I wouldn't be able to defend that position.
You talk about mountains and that sort of topography.
Yeah.
Okay. Well, I mean, to be honest, even with a flat Earth, I think it goes without saying there's mountains and valleys, but yeah. Okay, carry on then.
Well, yeah, that's your idea of it. Where I just have a realist view and say that the mountains and valleys obviously is a topography and therefore not flat. Flat being a 2-dimensional plane. But
so
the water level
right
is horizontal. Right, so that's where we would make the distinction. Where it's not the Earth. The flat Earth is a misnomer. The Earth has a topography. It rises above the water level. So obviously it came about. This I went to do the Bedford levels with but my son a camera so he can get out a bit, and we went to go and do the Bedford levels, and we sat in the dinghy. My lad was the lad in the dinghy when Dr. John went to Bedford levels April-ish time last year.
Okay.
So we did that, and all the time I'm sat there in the dinghy, I've been I'm thinking, I don't understand what's going on here. What I couldn't understand from a practical sense of what exactly was going on and what they were exactly trying to do. Because to me it seemed that they were trying to measure or check if the water was level, but with the Bedford level, yeah. Yeah, would you agree with that? Is the initial test?
Well, for those who don't know, Bedford level is the one done by Samuel Burley Rowbotham as part of a bet, wasn't it, in 18 whatever? And it's the Bedford level canal, which is 6, 7, 8 miles long and straight. 6. There we go.
Yeah, but I mean, it's not anymore. There's a big sluice gate in the middle of it. So
oh dear.
Yeah, so you're only going to get 3 as a maximum.
So what Rowbotham wanted to do was prove that the water did not curve, that it was straight, flat, level, without curvature. And it was a bet with someone else, I forget the other guy's name, who obviously believed that there was curve brought about by the curve of the Earth. And that was what the Bedford level experiment was about. So you've tried to recreate it?
No, we just went there and obviously filmed what they were doing. Now, I don't like the idea of that test. I thought, when I was there, I thought that doesn't really fit. Something didn't seem right, because I mean, the whole premise of it was, I don't know. I guess it just seems wrong that they were checking to make sure that the water was level. Right? You get it. It doesn't sound right, because the water is level, right? So if they were checking that the water was level, then everybody knows the water to be level. So what they must have been checking.
Not everybody knows that level to be curved. They're in the argument.
Yeah, well, that was exactly. So the question then becomes, what is level? Now, I've got a background in surveying, in building construction. So
interesting. Okay.
I know level to be horizontal.
Go on, carry on. Because I'm sure we're going to discuss this.
Yeah, so the level obviously is, to me, it was horizontal. So that's what led me on this journey, right? So not to say that I'm a flat earther. I'm just, my initial statement, and always has been, that the water level, and the meaning of the word level, is just the practical use of the word horizontal. Means the same thing.
No. but we can argue the toss about that.
I'm not arguing about it. I'm just saying this is why I'm here, right? Because, and then, like I was trying to explain to you the other day as well, I got into an argument on Twitter, a discussion on Twitter, where I said that the horizon does not rise to eye level, and because of that, I got called all sorts of names.
Right.
Because I don't know, because I was saying that level is because it is horizontal, it never rises or drops. It doesn't do anything. It just, that's what level means. It's a straight thing. So they would be parallel. They might appear to rise.
I disagree, but I say I disagree. But let's carry on for now. Yeah, carry on with your position.
Okay. So that was just my position, right? So I said that on Twitter, and then I got a load of abuse. Now, that abuse that I got, I initially thought, well, what do I have as a proof for that? And all I had was what I had been told, which wasn't enough for me. I had to then progress. I had to learn. I had to search out for it. So I came up with a method, 2, 3, 4 methods of how to prove that level would be horizontal. So
is this the test that was mentioned during our discussion the other day?
Well, there's no need to go straight into the test. There's a fair few more steps, but yeah, there's a practical test. But initially, it came to the logic, right, to understand how you would do that. And from talking to a lot of people, mostly on Twitter and through the Discords and through all of the different servers, you eventually get to talk to quite a few people about and ask them quite a few questions. Now, because I came into it because I had to prove to myself that level is horizontal, that I had to go through a lot of processes to, first of all, to understand how to prove things to myself. And that was the most entertaining thing. You might be interested, is logic is the main key to solving most of these things. So you have to go back to understand when you want a proof. It's normally people say mathematics is what gives you proof, but for me, researching it's logic, and the logic from geometry that actually gives you the proofs. So that's where, to me, that's where I came into this.
Well, just a minute ago, and I'll show it again. I showed a photograph, just a photograph of the horizon. I'd be interested to know, how do you explain a hard, sharp-edged horizon like that?
Where is this? Is this in your Discord?
No. It will. Are you watching the stream as well? If you watch the stream on mute, it will appear after about 30 seconds.
Your stream?
Yes.
Okay. No, I'm not watching your stream. Well, I thought we were in the Discord.
Well, we are in the Discord, but it's piped out to the stream.
Okay. Can you not post the picture in the Discord? Or?
Well, I can, but it's all set up. It's all set up on the stream, and I'm also having to watch things on Discord as well. I mean, if you just got the stream open, silent, then if you display any images, I'll pop them on there. If I display any images, I'll pop them on there, and we both see them. It's all right. I won't rush you with that. It's just what it is. It's just a picture of the sea. With a sharp-edged horizon, which you must have seen pictures like that, even if not this exact picture. So I just wondered how, if you're talking about, and I'm assuming you are, a continuous flat plane of water how can there be a sharp-edged horizon? Why does it stop at a certain point and not always fade away?
Sorry, I don't. What do you mean? Why does it sharp edge?
Well, yes. What is the horizon edge then? Is what I'm saying. If you've got a continuous plane of water that does not curve down to give you a horizon edge, so how can you get an edge, a visible edge?
Well, if that's the horizontal, right? It's a horizontal is a straight line.
No, you're looking away. Have you got the stream up so you can see it? Yeah. So you can see that image.
Yeah.
So you're looking towards the sun, and you can see the sun reflecting off the water, and that line from left to right is the horizon. It's as far as you can see. Now, I would say that's because beyond that point, the curve is sort of hiding what's beyond it.
Okay.
Or at that point, the curve is hiding what's beyond it. So that's why you see a sharp edge. So I'm wondering what your explanation would be for an edge like that.
It's a straight line, right? And the horizon is parallel to horizontal. Right? And the horizontal is a straight line. So I don't see anything wrong with that.
Well, first of all, are you talking about the horizontal left to right, or from you towards the sun, or both?
But yeah, that's what horizontal is, right? It's a position. It's a
plane.
Yeah. It's a two-dimensional plane.
So if there's no edge to that plane and it just goes on until it hits another continent, or even further, if this is the edge of the Pacific, you'd carry on seeing things get more and more compressed until eventually it faded out of view beyond your visual acuity. But you wouldn't get a sharp edge like that all of a sudden at a distance of, I don't know what that exact distance is, but a few miles.
Okay. So that's what you're putting. You're putting a distance to where that line is in the distance.
Yeah, I don't know what that particular distance is, whether it's 2, 5, 10 miles, however many miles that is. There is a distance beyond which that water is curved out of sight, behind itself, if you like.
Okay.
That is the horizon. So I'm wondering, how would that happen with just a continuous flat plane?
Just like that. And I'm struggling to understand what your problem is. That you think that curves off away in the distance, which that goes exactly with the. It seems like you're stuck halfway in between the Black Swan and some other.
No, I'm not. No, I'm not stuck between it at all. That instead of water, that could be salt flat. Oh, that's a bad word, isn't it? But a salt flat. I'm not arguing about what the distance is to the horizon. That was what whole thing with the Black Swan is. What I'm saying is there is a horizon. If you had a continuous flat plane, in effect, going on for hundreds, thousands of miles, you wouldn't get that sharp edge at that short distance. You would get it fading off, and perhaps tall things in the distance, whether it's mountains or whatever, way beyond, looking smaller and smaller as they get further and further away. But you would have a blur at that line always. Never a sharp edge.
You're predicting what would happen. Oh yeah. I mean, we do have spot ons done one. We haven't actually really made a big deal out of it yet or shown anything, but we can get stuff to disappear on a plane.
Are you not talking about with the Fresno lens, are you?
A what?
Was it a Fresno lens, the guy who had the stuff, and he had a little model ship across his table, and it apparently disappeared bottom up, but he was looking through a Fresno lens, one of those strange lenses that used to get at the back of a bus or something, so that the driver could look at what was right behind the bus.
No.
I'm sure it's called a Fresno lens.
No, Spot On did it with a P1000.
Okay, well, I'm not
we'll go to that some other time, but I mean, basically what we're saying is, or what we came down to is that if the Earth is a spherical object, P,
Yes.
which that's what you think, then the surface of liquid water must curve. Q.
Yes. Yes.
Right, so that's what you're saying. You're saying that water must curve.
Absolutely, because it would follow the gravitational equipotential of the Earth.
Okay,
so it would find its own level.
Yeah. Well, once you set up that logical statement, then the question surely is that the only thing you have to sort out is the surface of liquid water curved? Well, I'll give you a water level, the tool, that establishes a horizontal plane of reference, which I would say, therefore, not Q.
Okay, well, just coming up on screen, it should be coming up soon, is another picture. It's what I was talking about in our chat the other day, with a U-shaped level. In fact, it's just popped up for me now. Looking across both ends of the U, keeping them at eye level, across the surface of the two ends, you can see that the horizon is below that. Now, if that sea that's in front of you was continuous and a flat plane, then it would continue up to at least that level. But it doesn't. And yet, if you were stood on the seashore and you had that same equipment, it apparently would, within your eyesight's ability. You go up higher, that horizon would be dropping further and further. The reason being, as you are at a higher height, higher altitude, you are looking further around the curve. The curve is dropping away from you.
Well, I would just say that you are at a higher level than the level of the water. Obviously, you're at a different... Well, you says that 1,200 feet.
1,200 feet, absolutely.
Yeah. Well, you're 1,200 feet higher. And then that, in the distance there, is the perspective compression of that 1,200 feet. But, I mean, you do realise that isn't how you use a water level, right?
No, this is just someone's test to show horizon drop. You're right that you get the compression due to perspective, but that perspective has not compressed at the same point, has it?
What do you mean?
It's easier to see to the right of that level than the left because you've got the island in the way. But looking to the left, you can see the horizon line is comfortably below the red liquid.
Yeah, that's the level of the water.
Yeah, but hold on.
At the sea.
If that sea is carrying on in a continuous flat plane, it would reach a compressive point, but that would basically be at the same sort of point as the red liquid.
Why do you say that? You say that other level should rise, do you? Is that what you're saying? You're saying that sea level should rise to the level of 1,200 feet higher. So in the distance, you imagine that water level should rise 1,200 feet because that's the point that the guy that's taking the picture is looking at it from. So you imagine that the water level should rise to him, right?
Well, if not, then all that would be happening is that plane of water appears to be going up, 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 and suddenly stops. Why does it stop below that?
Well, see that 1,200 feet?
Yeah.
What does that actually mean to you? That's an elevation height, right?
Elevation, and I'm presuming he means above sea level. That would be the
okay. So it's 1,200 feet above the level of the water that's there. That's the sea in front of him, right?
Yeah.
Well, that's why there's a drop, right? There is a drop because there's 1,200 feet there.
Well, I'm going to change photos now. It'll take about 30 seconds to come through because you're talking about perspective. I've actually got two photos. One's a standard one and one's one I turned at 90 degrees. We'll let it come through. I'll tell you what it is, though, before it comes through. it's railway tracks, perspective looking along railway tracks, and the two rails appear to meet, as you'd expect, due to perspective. I think that's no one would argue
they
that.
don't, though, do they?
No, of course they don't,
Okay.
but they apparently do. If you were to, I don't know how much I can zoom that without it going all blurry. Oh, only one click. They apparently meet. So why doesn't the two planes of the level of those red liquids and the level of the seawater meet, or apparently meet?
Two different elevation
Now,
levels.
those two
They're
rails,
two different horizontals, aren't they?
Right.
There's
So now we look at
1,200 feet difference in between those.
Now we look at the next picture, which will come through in a second. It's railway tracks again.
Yeah, I can see them.
No, it's the second, because the first one's just standard railway tracks. The second one, I've turned the picture to 90 degrees. It'll come through in a moment. And you can imagine that one of those rails is the sea. The other is looking across the tops of those red liquids. They would still apparently meet a long, long distance away.
No, you've just flipped a horizontal
Yeah,
to a vertical.
No, I know. I'm using that. Imagine that one of those is looking across the top. Yes. Well, it's a thought experiment. One of those rails is looking across the top of the two red liquids. The other is the flat plane of the sea. They would, even though they are apart from each other, due to perspective, looking off in a distance, those two lines would meet, or apparently meet. But going back to that Malibu 1,200 foot high thing,
Yeah.
they don't apparently meet. One of them suddenly stops.
But both of them, geometrically, don't ever meet. Do they?
Not No, if you took an actual line, they would never meet because they're parallel.
So it's an optical thing that you're doing there. You're looking at something in the distance and saying, that's a bit weird.
Well, I'd like an explanation of why, in this example, the sea as a flat plane doesn't
two
carry it.
Different levels. But again, that isn't how you use a water level. Right? You would have to have one end of it at one end and the other end wherever you want to check the level.
I know exactly what you're talking about, but because then you could take two positions being level, even if they were hundreds of miles away, if you had enough hose, or round a corner. Absolutely, those two would be level. And I guess that's where we come on to what the hell is level.
Yeah.
So how would you define level?
Horizontal.
And
very
you said
simple.
you're a surveyor?
I have done. Yeah, I have
done surveying.
Done surveying, yes.
Yeah, because I did a bit of digging, and this is a civil engineering blog. Again, it will take a while to come through to you. I'll read bits, but you'll see it in a minute. Horizontal plane is a plane through a point. It is a horizontal plane through a point is a plane tangential to the level surface at that point. It is therefore perpendicular to the plumb line through the point. I don't think you would disagree with that if you dropped the plumb.
Well, I don't know.
Line to get
Where's tangential, right? Because that's sort of saying that horizontal plane through a point is a plane tangential to the level surface. So what would that mean to you? With the point that is therefore perpendicular to, I mean, I understand that horizontal is definitely perpendicular to the plumb line through the point.
Yeah. Okay, I'm happy to agree that. Yeah, you drop a plumb line, you take the perpendicular to that to give you the horizontal plane, and any line along that plane is a straight line.
Okay.
That is also perpendicular to the plumb line, isn't it?
Yeah. Right. So how would you imagine that you would establish that horizontal?
Well, if you're talking about what technical equipment?
Yeah.
Is that what you mean? Yeah. Well, I'm not a surveyor, so I can't describe all the equipment. But if you've got your vertical and you can read off exactly 90 degrees to that vertical, that is your horizontal. Yeah. Using whatever technical means you need to do to get that.
Let's say the tool to establish that plumb line is called a plumb bob.
Yep.
And you've seen a plumb bob?
Yes, indeed.
It's a weight on a piece of string. So that's the tool for establishing a vertical. What is the tool that establishes the horizontal?
I don't know what tool as a surveyor uses.
Well,
but I know they use a tool to establish 90 degrees perpendicular to that vertical, to that plumb bob line.
You would call that tool a level.
Okay.
Now, that level is horizontal, right? It's a tool for establishing a horizontal plane of reference.
Yes, it's a tool. I can accede to that. That establishes your horizontal plane. Yes.
Okay, so when that line that you've just read out said that a horizontal plane through a point is a plane tangential to the level surface. Well, the horizontal plane is the level surface. So what's the tangent bit there in that thing, do you reckon?
Well, it's because a level surface, let me go up a bit further on up there. A level surface is defined as a curved surface which at each point is perpendicular to the direction of gravity at that point. The surface of still water is a truly level surface. Any surface parallel to the mean spheroidal surface of the Earth, therefore, is a level surface. So basically, you've got your plumb bob, you take 90 degrees, and if you looked along that 90 degrees, that horizontal, you are looking along the horizontal. You step forward a step, took another vertical, another plumb bob, you would have a new and different horizontal. It would intersect with your first one. It would be very close to the first one, but it would not be identical to the first one. Level follows the surface. If you imagined your Earth, either flat or a ball, as perfectly smooth, either a perfect smooth flat surface or a perfect smooth sphere. I've forgotten where I was going with that. If the Earth was a perfectly flat surface, then level would equal horizontal throughout. As it's a sphere, you've got horizontal at one point. You move forward a bit, you'd have a new horizontal, because level would be a sphere around the sphere.
Okay. I can see where I think you might be struggling.
Well, I'm not struggling.
Okay.
And there's a cheapo diagram's just going to come up as well.
Yeah. Okay. Well, which geometry are you using?
What do you mean?
What do you mean? You do understand what geometry means? Did we tell you this the other day?
We are looking at surveyors' websites here.
Yeah. But I mean, like,
we're talking about.
Like I say, like use your brain and use your logic here, right? But don't be looking at pictures like that.
Well,
because they may influence you, right? Just think for a second, right?
Well, Ben, I tell you, when we were chatting the other day,
yeah,
right, we just started. I can't remember how the conversation started. And we got into this sort of stuff. I had not done any looking into it. Now I've looked into it briefly today, so I'd have some stuff for tonight, and it's come up with exactly what I said in this diagram. For instance, if you're stood near the edge of that sea level, you got that vertical line. You take your 90 degrees, and that gives you a horizontal. If you moved a little further forward into the sea or up the mountain, you take a vertical, it would be a slightly different vertical that would give you another horizontal.
I think it would be a different vertical. So would it have a different?
Yes, it would be a different vertical.
And what would you measure that angular difference of that vertical from?
Well, you'd use a plumb bob again. Anywhere around that sphere, the plumb bob would always point down.
Oh, right. So it would always be vertical. So you'd never be able to measure a deviation of a vertical because your frame of reference would actually be vertical. So you would never be able to tell a difference, would you?
I'm not quite sure what you mean about that. But
well, how would you measure an angular difference between two verticals?
I don't know what you would need to do to actually measure that, but it certainly can be done. And
You're saying it certainly can be done, but
and I'll show you in a minute. Yeah, I'll show you in a minute.
Oh, so it can be done, but you don't know how it can be done, but you're just going to tell us in a minute. Okay.
Yes.
Okay.
But
so
going back to this
this
second site, it says again, a level surface is the equity.
Yes, I can understand that you can read that sort of stuff, and I'm trying to keep away from actually giving you any definitions or anything, because I'm hoping that you're going to use your brain.
Sorry, mate, I honestly, I just missed what you said. Can you say that again?
I said I'm hoping that I don't have to start giving you definitions and this turn into a semantical thing where you just give me a definition and I'll give you a definition, and mine will say levels horizontal and yours will say level curves. They're just two different things about the same argument that we're going to be talking about and we're hoping to try and sort out.
Well, the reason I looked up this stuff and this definitions is in case I was wrong about something.
Okay.
And, following our conversation. And however far my understanding goes, it ties up with what these surveyors' websites... I know this is just this is basic stuff, and I'm sure that with surveying there's all sorts of crap that I just would not... And I presume most people just would not know or understand. Oh, someone's just suggested in chat, and I have no idea, that perhaps you'd use two theodolites. I presume that's talking about the two verticals. I don't know about that.
Yeah, see, you want to watch what you're doing here, listening to people in your chat. Because these people in your chat will be saying things that they aren't willing to talk about. They're going to get you to jump into the areas that they're not scared. They're too scared to come and talk to us about.
Well, no, I'm just saying, I admitted quite freely that I don't know what tool they would use to establish the horizontal from that vertical.
Well, that's what I'm hoping to make this very simple, to hopefully get you to understand something and learn something.
Well, here's another image that demonstrates the whole idea. You've got, it's going to come through to you shortly. It just shows two verticals, a horizontal from the first vertical. If you took a horizontal on the second vertical, you can see at 90 degrees to that second vertical. Sorry, I'll wait till it comes through, really. That's not fair otherwise. There we go. You take that 6 o'clock to 12 o'clock vertical with the 90 degree box. It gives you a horizontal line.
Who gave you this?
If you take the other...
Please.
I've not got the actual link.
Do you know what a vertical is?
Vertical would be directly downwards towards the centre of gravity.
Vertical is a position established by a plumb bob. Now,
yes, so
one of those looks like it might possibly be vertical, but both of those cannot be vertical. Now, you understand that, right? Your understanding of vertical doesn't mean that you can draw a picture like that and then make a vertical do that.
Right. If you were this isn't my image. It is one I got off a surveying website or something like that. If you were stood at that 12 o'clock position where we got the 90
we stood
degree
on
box,
a ball.
Yep, you stood at the very top of that ball. Okay. You drop a plumb bob. It would point down that vertical line directly down the centre of the image. Okay. You would agree with that, I presume. And if you drew...
you stood on top of a ball, yes. You'd have to stand at that point, otherwise you'd fall off it, wouldn't you?
Oh, my goodness. We're talking a ball the size of the Earth with gravity. If you then move round to the other one, where you've got the arrows position C, if you... On the Earth model...
Which geometry are you using,
It doesn't matter what
please.
geometry.
It does.
Okay. No, well, let me finish my point and then you can argue it, okay? If you stood at the top one, we'll say that's London. You drop a plumb bob and draw your horizontal. That's fine. You move across to Paris, which is where the C's arrow is. You drop a plumb bob. That gives you a vertical, which is pointing in the direction of those arrows. At that point, if you drew another horizontal from it, it would not be parallel to the first horizontal, but it would intersect somewhere above D. Okay, so that is the model. That is how I would say the Earth works. And you could carry that all the way around. You could go to Australia at the 5 o'clock position, you drop another one, and it is totally different horizontal. So you know where I'm coming from now. So what are you going to say is wrong with that?
Yeah, that's what you're forced in. Your model forces you into that position. But it's,
really
it's not a very logical position to take, is it?
Why?
Because, like I have asked you which geometry you were using. Now, you don't know, do you?
I don't need to use a geometry. If I stand here now and drop a plumb bob, I know it's going to point straight to the floor. If you stand where you are and drop a plumb bob, it's going to point straight to the floor. But my vertical plumb bob will have a slightly different angle. My plumb bob would not be parallel to your plumb bob.
And you're saying that because you have a model that you have to. It dictates that to you. But I mean, well, there's no reference frame that you can use to do that. So,
well, coming up is yet another image for you. I do know you've got some images, so by all means, in a minute, you chuck some of the images my way, and I'll put them up for you. Okay. Coming through now is a picture of the Verrazano Narrows suspension bridge, which is from Brooklyn, and I think it's from Brooklyn to Staten Island. Those towers are 211 meters tall, and that central span is 4,260 feet. That's 1.3 kilometers. The tops of those towers are 1 5/8 inches, or 4.1275 centimeters, further apart than the bottoms.
That's a calculation, right?
Because
that's a calculation.
If you stood at the top of either of those towers and dropped the plumb bob,
a measurement.
I'm sure that if you dropped the plumb bob from the top of either of those towers, they would be absolutely vertical. But those two verticals, those two towers, are not parallel to each other, and that's fact.
It's not fact. It's a calculation. It's never been measured. You've just said that because somebody's told you. One of your friends has told you to say that.
I've spoken. No. I have spoken to no one about this. No one about this.
Oh.
No one else has seen that any of this evidence that I've presented tonight. No one.
Oh, so it is a calculation, and that number that you've just give us. What was that number again? Can you?
Right. The distance between them is 4,260 feet, which is 1.3 kilometers, or 0.8 miles. The tops of the towers are 1 5/8 inches further apart than the bottoms, which is converted 4.1275 centimeters.
Okay. And that's a calculation.
Well, those are figures that I got off a website about the Verrazano Bridge.
It's not a measurement, is it? Nobody's measured that.
Well, the figures are there. How they got them, I guess.
Yeah, they calculated
can't. So how would they calculate them and get them wrong? Because if they were absolutely parallel, or you mean that they just assume the Earth is curved, and therefore, if it was 211 meters tall, they would have to be that further apart?
Yeah. Somebody's done a calculation for you, and you've just read the numbers from a page somewhere and imagined. I mean. The idea was put into your head that was a measurement by you. You did that.
Well, no. What I did was I looked, because I'm aware that suspension bridge towers and large constructions, have to be very large constructions, have to take into account the curvature of the Earth, and that one does.
Okay. I mean, I expected this. I mean, you've come a bit heavy, right? Because I was just talking about how I got here. And I think I said that I think level is horizontal. And then you've fired all of these stuff. You're not going to burn yourself out, are you?
No, just going back to that hand-drawn diagram, which is not hand drawn by me. It came off the surveying estimating website. It was to talk about the fact that horizontal is not the same as level. I know you're saying it is, but I was saying it isn't, and everything I've read seems to confirm that. It's just changed over to it now.
Yeah. So have you ever looked in a dictionary?
Well, I've just looked up survey. That words can have different meanings, can't they? When they're used in a profession from the everyday use. Look at the word theory. When you talk about scientific theory, that's not the same as you say, well, I've got a theory that, do you know what I mean? This idea I just pulled out my butt is my theory. That's not a scientific theory, because a scientific theory has a very particular definition. So when you're talking about a level surface on, with regard to the Earth, then it's a surface that's curved following the curve of the Earth.
Okay, so
whereas if you say
you're saying
picture on the wall,
level is
picture
curved.
on the wall is level with something different.
Yeah.
Yes.
Okay.
Yes.
Brilliant. Well, I mean that's good, because that's what my test does, right?
Okay. Oh well, that is interesting.
Yeah.
And just now, this is where this guy. I don't know if you heard my intro, but I'm doing 1 minute debunk videos asking for people to submit. And one guy, Flow Rider, submitted something about this, which I mentioned when I was chatting with you the other day, Bev, to do with tow tanks, which I'd never even heard of before. And tow tanks are the large, long tanks of water that they use for testing the way a ship's hull with a model would flow through the water and how it would cope with waves and so on. And I said to you, following this information from Flow Rider, that long tow tanks, the cranes run on rails, and those rails, because of the length of them, have to take into account the curve of the Earth. And here it said the tow tank at the Hamburg ship model basin has a length of 300 meters. The rails are 1.8 millimeter higher in the middle than at the ends, and the 1,324 meter long tank at the Krylov State Research Center in Russia is 34.3 millimeters higher in the middle. Because I know that you guys laughed at me when I said that.
Okay. Yeah.
And I guess the last thing I'll do, and it's the last bit of evidence I've got, so if I show that and then I'll let you really respond. It's going to come through shortly. It's a little clip of video for those who haven't seen one before. It's a tow tank. Now, when I tested this earlier, the video seemed to come through choppy for some reason, so I'm sorry about that. It starts off with a view at one end with little wave makers, so I'll just kick that off. And these things are pushing backwards and forwards like in a swimming pool, making waves, and the model boat's pulled along on a gantry, running on those rails that enables them to test how the ship's hull would cope with the water, waving and so on. And it's those rails that have to be curved to allow the curve of the Earth. Not so much with this one, which is only a 45 metre long tank, but with longer tanks, because they need to follow the curve of the Earth. And that's the last of that evidence. But I thought that was quite interesting. And I will give big props to Flow Rider, who pointed out this Earth curve evidence, which you may well dispute, of course. But big thanks to Flow Rider. So that was the evidence that I'd gathered, Bev. So thank you for being patient while we go through that. And yeah. So what do you think of them apples then?
Well, I don't know. You didn't really give me chance to get through the basic logic behind this, and you've obviously come to your conclusions way before. I mean,
well, I'll show my evidence, mate, and please go ahead and go through your logic and take me through it then. Okay.
So what we've got is I'll go on your Discord.
So what, to drop an image or something, is it, mate?
Well, I can drop some images in if you want me to, but I mean, I'm trying to...
Well, if you've got them, and then I'll put them up on the screen for people to see.
Okay, right. So, okay. Let me just sort this out. If we're...
Yeah, of course.
So you may have got all of your stuff sorted, but you've just... dumped a load of stuff on me.
I know.
Okay, so we've got a... oh, wait a minute. Am I not even in the right Discord, am I? Where's your Discord? Right, so the logical explanation of the old black swan that you said was a distance, like I said, is that your evidence for a curved water level All of that stuff that you just came up with, because that's all we're talking about is level, right? And
yes, that's my evidence for why level does not mean a flat horizontal plane.
But it does mean perpendicular to the plumb line.
Absolutely, on every single.
But that is horizontal, right? Because horizontal is perpendicular to the plumb line.
But the plumb lines are not parallel. So if you had two non-parallel lines, how could the perpendiculars be the same?
So you do say it is horizontal, but that it isn't horizontal.
It's horizontal at that point. If you take a plumb line and take 90 degrees, at that point where you're standing, you've drawn, your perpendicular is horizontal. If you move away a bit and dropped another plumb line, took another perpendicular, that horizontal differs from the first horizontal.
Okay, so can we establish which geometry you are using? Or are you just going to freestyle a geometry?
It's not a case of freestyling
geometry. It is, because I'm going to give you Euclidean geometry. Now, I'm going to give you the definitions within Euclidean geometry to define all of this stuff that we're talking about. Because it is a logical system, right? The Euclidean geometry is, that's why I keep saying about this, right? That when I went to go and find my proof, I found geometry, because geometry is the way you get your proofs.
You get your geometry and you work out various calculations and so on. But then if you go and apply that to the real world, those two, for instance, the two towers of suspension bridge, they would be under stresses because you'd built them wrong.
Sorry?
Well, those two towers of the suspension bridge, they are further apart. According to my evidence, they're further apart at the top than the bottom, because each of them must be vertical, and those two verticals differ. If you made them parallel to each other, they would be, in effect, leaning towards each other, which means you've suffered. They've not got the same structural integrity. They'd be leaning, or one of them would be leaning towards the other.
Okay, well, yeah, I think this is the problem you've got, is that your geometry that you're going to be using doesn't work.
And the bridge hasn't fallen down.
But yes, okay. You said that horizontal, level is horizontal at a point. Well,
that's a point, yes.
Okay, well, definition number 1 in Euclidean elements is...
Sorry, do you have... do you have a diagram or an image you want me to pop up or something? Or not yet?
No. Like, we're just going through this. Do you... Euclidean geometry, do you want me to get you a picture of that? Or you're going to trust that definition 1 for the Euclidean geometry is a point is that of which has no parts. It's nothing. That's definition 1.
Sorry, this is go give us the definition and what you're defining.
A point is that of which has no parts.
Okay.
Well, that can't be horizontal, because a horizontal is a line, because it's perpendicular.
Right. What I was agreeing to is, if you stood at a place, you drop a plumb bob.
Yep.
And then from that line you took a perpendicular and looked along that perpendicular. Yep. That is your horizontal.
Okay. Well, then that is a straight line. Then it's not a point. That
horizontal is a straight line that intersects your vertical at 90 degrees.
Okay, because that's what perpendicular is.
Absolutely.
It's a relationship of one straight line to another.
Yep.
Right, so that vertical and that horizontal are set as lines as defined by Euclidean geometry.
Yeah, well, so far I've got no problem with that.
Okay, so then when you move, you have a then set, according to your geometry, a new horizontal and a new vertical.
Well, if you drop a vertical, because it goes to the centre of a ball, by definition, it cannot be parallel to the first vertical.
Is that because your models dictated that?
Well, the shape of the Earth has dictated that.
What dictated that the vertical is at a different vertical than another vertical?
Yes, every point on the Earth has its own vertical.
Okay, well, that's
Because
not
it's a
what a
sphere.
vertical is it? A vertical and a horizontal are perpendicular,
Well,
as defined in Euclidean geometry, right? A perpendicular is the relationship of one line to another.
yeah. Well, Bev sat in his office or wherever you are, drops a perpendicular, drops a plumb line, giving him a vertical. And you look across that vertical at 90 degrees. You're looking across along a horizontal plane, perpendicular to your plumb bob. Where I'm sat, if I do the same, and I drop a plumb bob, look across it at exactly a perpendicular angle, I've drawn a new horizontal plane. Our two horizontal planes would intersect, but they would be at an angle.
Okay, right. Well, here we get to the test, right? Because that's obviously what goes through your mind, right? It's like you guys go to vertical, whereas I go to horizontal. So,
but you can only get that horizontal from the vertical.
Okay, but they are perpendicular. They are related geometrically through Euclidean geometry by the term perpendicular.
Can I ask you a sort of side question? Do you believe in gravity?
Sorry?
Do you believe in gravity?
I don't believe.
Yes. Or do you accept
I don't
gravity?
believe in anything.
Do you accept gravity as a thing? I don't get.
It's a word.
Well, plenty of people don't.
Okay. Well, that acts. I believe we are quite similar in the way that acts. In the same way as a plumb bob does, right? In your model, a plumb bob, which is the reality tool that I use, they're the same thing. Would you agree to that?
So a plumb bob and what?
And your gravity, they act in the same manner.
Direction?
Yes.
Yeah,
the same
direction,
vector,
yeah.
Let's call it.
Yeah,
right?
I mean, I suppose you may say a plumb bob points down towards us. Well, points downwards for whatever reason. I would say plumb bob.
It just
points
establishes
down
a vertical. Yeah, no, it just establishes a vertical.
Okay, I guess there's no need to argue about that. Yeah. Okay, we agree.
There's no direction to it, up or down. It's just a line, right?
Well, there is a direction.
Both. It's a vertical. Like it doesn't have an up or a down, does it? Or do you think it does? Do you want to give it? I've heard of a lot of people say that vertical means up. Would you agree with that?
Well, I tell you what, I will answer that, and then what I'd like to do is read out some super chats. While it's just a handful, okay?
Okay.
Vertical. I would define vertical as in following the force of gravity towards the centre of gravity, and as the centre of gravity is pretty much the centre of the spherical Earth, it's basically pointing to the middle of the ball.
Okay.
And so everywhere around that ball, if you point towards the middle, the opposite direction is outwards, and those directions are at angles to each other, getting further apart. Hence why those suspension bridge things would lean apart. I know you're disputing that, but that would be why. Okay. So those super chats, if I quickly read them out. Some of them, I've not read them yet. Some of them may actually do points to you, Bev, okay? Jessica G, super chat $5 US saying, I don't know Jessica G, do you? Is that a name you recognise?
I would imagine you're not going to say anything pleasant.
Oh, right, okay. Well, there's nothing rude here. People say that proof is in maths, but I believe proof is in geometry and logic. Bev 2020. Yeah. Bev 2020, you can't make this stuff up. Any response to that?
What's up with that?
Okay. Mark Green, super chatted £9.99, said, "Hi, I'll put my banana plant on the phone. You'll have a more fruitful conversation with that." Thank you for that, Mark. And Esteban Ilabaca, hope I said that right. Oh, I don't recognise that currency. It's $2,500, but they're CLP dollars. What's CLP? Do you know what that is? I don't know. CLP. Bev, this is what reciprocal zenith angles demonstrates and evidentiate. Angles add up to more than 180 degrees, therefore not flat.
Yeah, he doesn't understand what reciprocal leveling is.
Well, that was the super chats. Thanks for those guys. Appreciate them. Right, yeah. So that's my verticals.
So vertical, and you would say it acts perpendicular. Like perpendicular to you is a relationship of a straight line to another straight line.
You've got a vertical straight line. Perpendicular to that is another straight line, which is horizontal. Yes.
So that's a definite.
Which you can expand to that to a horizontal plane, of course.
Okay, so that and like in a plane, mathematically is described as an indefinite, right? It doesn't.
Yeah.
Okay, so that
because if I'm stood there looking horizontally, unless something gets in the way, I could look forever, can't I? In that horizontal direction.
Well, we are just talking about a horizontal at the minute on a plane, right? Not your eyesight or anything.
No. But I mean, it doesn't. That horizontal plane doesn't curve. It doesn't bump. And assuming it's within my visual acuity, I can keep looking along that horizontal.
Mm-hmm. Okay. So you would agree that surveyors have tools that establish a horizontal. Now, I know we're not going to go to the water at the minute. Let's just say an auto level or a theodolite or a laser level. They're all tools that are called levels that surveyors use to establish a horizontal, right? Would you agree with that?
They establish horizontals, yes.
Okay, so there are... I've put some things in your general chat.
Oh, right, okay. Let me just go over to there.
There's 3 drawings there. You start off with the first one, which would be the one that
what I'll do is I'll just load them. I just sort of load them up, and then I'll pop them up one at a time. I'll try and keep them in order as well. Right, I've got the first one. Let me transition that across. So that should be coming up in about 30 seconds. Don't know if it's going to let me... I'll see if I can zoom it a bit. There we go. So it should be coming through.
Okay. Let's have a look. Oh, it's a bit behind, isn't it? Right, so...
It is, I'm afraid. It's always the way. We tried to run a quiz one night with the people answering and some people on Discord answering questions. That was interesting.
You should just let them into your Discord.
No, people can come into my Discord.
Okay, so you can see there that this is differential leveling. It's a surveying technique for...
measure.
Well, just establishing a horizontal and transversing a benchmark at a known benchmark at one point to an unknown at the other point.
Yep. Basically, you've carried your level, in this case, 1 mile along, and those 2 points should be the same.
Yeah. What we've done is we're going to bang a stick in at one end.
You've got your datum.
Yeah, and we are then going to mark that and then transverse that all the way to the other end and get a point up the other end that is on the same horizontal, right? Would you agree that is what a surveying team would do? They are able to.
Yes, that's what they do. Yes,
Okay.
That's about as far as my knowledge goes. But yes, I know they take a measure and then remeasure and work their way along with those.
Okay, so we mark a horizontal point at one end. We can put a point in the middle and go to the far end as well, right? So there would be 3 points there, all on the same horizontal, same straight line, right? You go on, get to the next one.
All right. Done that. It'll take a while to come through.
So obviously, when you're doing this, you want to have somewhere that's got to be similar sort of level, right? You don't want to have to go in at the other end and find that you've got 2 meters. You've got to stick to.
Yeah.
Obviously, that's no good because the test's not going to be good. So, in order to find a level bit of land,
image.
we go to a canal, right? Because at the side of the canal, that's one of the like levelest lands that you're ever going to get. So you can establish a horizontal there, and you know you're going to be within, you know, like the towpath going up and down. It's going to be within a foot or two. So banging them sticks at the side is going to be quite easy to do, right? So test number 2 can be you can measure from the water to the stick at either end as well. So you've established your horizontal with marks, and then you can also measure from the height of the water to that line as well. Would you agree with that? That is that's a thing that you can also do.
Can I just ask you a question, sort of going back a step? Was this so if you called the, on this image, the datum peg on the left, A, and the one on the right, B, was this just to get those two datum pegs, A and B, so that they are the same height above the water, or
well, no, the first one, like we said, we've just banged some pegs in. We've been out there and measured it, you know, a 1 mile distance. So we've measured the one end and the other end and the centre point. And then we've gone and we've knocked a post in, and then we've marked somewhere on that post and said, right, this is the datum, and we're going to transfer that all the way to the other end, right, as a horizontal. And then we've got a mark, and we've put the mark on the other end. So it's got 2 marks on that are on the same horizontal each end of this 1 mile post, right?
Can I just ask, what's the margin of error in this equipment?
What the?
Maybe you don't know. You know, just wonder how. Obviously, it's pretty darn accurate.
Yeah.
Obviously, if they're relying on this for surveying, but I just wondered, what is the level of accuracy? Do you happen to know? I'm not going to hold you to that.
Yes, it's 1 millimeter for a
over
1 kilometer double run.
What, there and back again?
Yes.
Do you mean 1 millimeter? Within 1 millimeter of?
Yeah, the accuracy of the tool is within 1 millimeter. Because I mean, how much do you want to measure?
Yeah, no, that's fair enough. You know, I was just asking because I don't know about that.
Yeah, a 32 times scope on an auto level, which is one of the best sort of scopes that they do on auto levels, will give you that 1 millimeter. If you were to go 24 times scope or a 20 times scope, that error would obviously be a bit, maybe 1.2 2 millimeter. I don't know, but I mean, the tool we're using and we're going to be asking the surveyors to use would be an auto level or whatever. I mean, doesn't really matter, right, how that horizontal is marked within that first one. Surveyors could do it, is the point, right? That horizontal can be set and it can be marked.
Okay.
So then the next step would be to measure how high above the canal water these marks are.
Yeah.
Right, okay.
And would you expect those 2 marks to be the same level above the water?
Yeah. Would you?
Well, that's what I'm wondering, because it depends, doesn't it? I'm not quite sure what you're trying to establish.
Well,
perhaps you better carry on with the explanation.
We can do. Go on. Give us the next one then as well.
Oh, the next picture, yeah. 1 second.
So I'm just saying that these are things that we can do, right? We can get some surveyors and you can get a tool, an auto level, and establish this horizontal, and you can mark the horizontal on both ends, and then you can check the water level with the marks that you've just made as well, you know. That can be measured. It can be done at the side
Right.
of the canal.
So have you got your third image up? Has it come up?
Yeah.
Oh, blimey! I've just nearly screwed up what I'm looking at. Let me. Okay, yeah. Carry on. So you got image 3.
Right. So this is now a water level, which really it's just a hose pipe.
Yep.
Right. It's a hose pipe 1 mile long, and you put little vials on the end that you can see. And then you fill it up with water.
Yep.
Right. Then you go to one end of it and you put it next to the mark that you've just done with the horizontal.
Mm-hmm.
And then you check the other end. And then that would let you know. That whatever happens, right? That you could then use that to measure. Yeah? Would you agree?
Well, I'm not quite to measure. What are you saying? First of all, with regard to the water level, the hose and the vials, no problem with that. You pour liquid in it until it reaches a certain level in one vial. It would be level with the vial at the other end.
Okay. So that
So having put in your datum pegs each end, and perhaps strap these vials to the pegs, filling the water at end A until it matched your first mark. So you're saying, or are you saying, that if you then walk to B, where your other vial is strapped, that water level would match the mark at that end?
I am saying that. Yeah, that's what I expect, because I say that
is your test.
I say that level is horrible. Well, there is another bit to the test. Let me give you this because
have you calculated how much curve there should be given the size of the Earth, if the Earth is a sphere, and so how much you would expect it to differ?
Why do you say I would calculate? What do I need to calculate? I've just shown you the exact things that we can do practically in reality.
You're showing what you're going to do to try and show that it's flat.
Yeah.
So what I'm saying is, basically, I suppose, is a mile long enough for any difference between flat and curved to show itself? Or are you going to have a longer
Do you
distance?
not think it is? I mean, I'd say it's horizontal. I mean, how far would you say you have to go before a horizontal would curve in your...
But before a level would curve, you mean?
Well, yeah. I mean, like...
Yeah. Well, I have not really... I mean, you're showing me this test right here, right now, and so I've not seen this test before. I would expect there to be curvature. How much, I don't know.
Okay, well, like before you said that level is perpendicular to the vertical at a point. Right now,
yes.
I know we just ruined your point with the geometry because it's a line, but where would you say that would be in that water level? Because that water level is a tool that has 2 vials at each end of a mile. Where would that point that is horizontal be in your, like to go along with the geometry that you don't have? Right, where would that?
No. Okay, let's change your mile to 100 miles. Okay, we've just
no. Let's keep it at a mile, or let's put it at 2 miles then to make it easy for you.
Well, it makes no odds. What I'm saying is, okay, a long distance. Okay, you've got a really long hose and 2 vials. Okay,
is a mile not long enough for you?
I don't know, but what I'm saying is, if we really accentuated
have you done any of your maths?
If it's flat, it will make no damn difference at all anyway, will it? Because it would always be the same.
It's horizontal, what I'm saying is, yeah, okay.
So if you started at position A, you've got your pegs, and you've established what you think is your flattened...
Do you want to put my... I've got another one.
Well, wait a sec, I'll just make this point. Okay, so at point A, you've got your liquid halfway up your vial, and at point B, the liquid is halfway up the vial. So I would say those two are level with each other, and I guess you would say those two are level with each other. You'd have no problem with that, because. So going back to A again, at that vertical point where you've got your half-filled vial, if you drew a horizontal from it, inscribed it with a you shine a laser at exactly horizontal, perpendicular to that. You then go to the other end and do the same. Those two lasers would cross at an angle, accentuating it, looking at your two lines towards the diagram bit in the middle.
So then two horizontals would meet at an angle. How would you measure that angle?
Well, absolutely. If that was...
What would you measure that angle in reference to?
Each other.
Horizontal. So you'd measure the deviance of a horizontal from how much it deviates from the horizontal.
I'm wondering if I can try.
It's a bit tricky, isn't it? It's because you've not got your geometry sorted. You're just making it up.
No, I'm not making it up.
Yeah, you are. You've completely forgot about postulate number 2.
Look, if you're on a curved surface, if that 1 mile or 10 miles or 100 miles is a curve with two differing verticals, you would have two differing horizontals. For the sake of argument, it could be those two lines you've got drawn. Okay. Therefore, they would cross at an angle if that was two different verticals on a curved shape.
Yeah. Do you want to have a look at? I've just done
You've done another one.
Well, yeah, I've done. This is the model, let's say, for the actual water level test, because I mean that is just a water level, and I've just walked you through
this photograph, yeah. The photo.
Yeah.
Okay, let me drop that in. Okay,
right.
That now should be. Let me just make sure it's going to come through. Yeah, it should be coming through.
Right, so this is an arrangement of water levels, right? Because like you just shown that you have a problem that the center, you say, because if you do two horizontals and they meet at an angle, like you said, that's higher in the middle.
Yes.
Okay.
Yeah, it would be.
Okay, so what we've got here is we've got a big water level goes from one end to the other, but it's got a T-junction in the centre, so it's got a little offshoot. So the green water level. Right.
Sorry, you got to bear with me a bit because I'm colourblind to red and green. That's the bottom part?
Oh, right, okay. Yeah, the it goes from the outside to the outside, and then there's one in the centre. Yeah. At a T-junction. So that's one water level that has 3 points, A, B, and C.
Yep.
Right, and then there are two separate water levels. One that goes from A to B, and one that goes from B to C, or C to B. Right, those outside ones check the middle with the outside.
Yeah.
Right, so that is the design, right, of the test to show that level is horizontal. Because the only way that all of those horizontal planes can be on the same horizontal plane is with a shared segment.
No. If I'm just looking at that, picturing that in my mind, if that piece of wood was a bloody long curve, if that piece of wood was 5 miles long and following the curve of the Earth, then I would still expect the two files at A to match the two files at C to match the three at B.
Yeah, 'cause that's what I say. They would all have to be on the same horizontal plane.
No. It wouldn't be.
Yeah, because A to C is a horizontal plane, right? You would give us that. They are level. Right? From A, the big one, from A to C is level, right?
It's not. That's where we're going.
Oh, no, so from A to C isn't level.
No. Sorry, you said horizontal. A to C and to B is level.
Right, okay.
But that's not the same as saying it's horizontal.
So they're all the same horizontal. They're all on the same level.
They're on the same level, not on the same horizontal. Well, at this scale, they probably are exactly horizontal because there's a very small scale. But scaling that up, if you're talking long distances,
Yeah.
London, Paris, and I don't know, Dusseldorf or something, then yes, they'll all be on the same level. Let's say a foot above sea level. However, they are not all on the same plane.
Okay,
There's no problem with that on a spherical Earth.
But what we just did before, when we were... So see, the tool, a level, the auto level that we established at the beginning, right, that establishes a horizontal, right? So what you're saying, I mean, Jesse Kozlowski has said this, that the water level drops from horizontal. You wouldn't have a guess at what rate he says he does it as well. He says he does it at 8 inches per mile squared. Do you want me to get you a clip of it so you can play it for everyone?
Well,
but is that what you're saying? Are you going along with that?
I suppose, in effect, if you're at point A, looking towards point B, looking across to point C, and they are, we're talking distances, not a few hundred meters, but
a mile. Let's keep it at mile.
Okay. A mile to B and a mile onto C.
No. Okay, then if you want to do that,
they are dropping. Now, that 8 inches per mile squared is just a rough guideline. It's close, but not exact. But that's the sort of thing we're talking about.
So they are dropping, but that would make the water run out, wouldn't it?
No, it wouldn't. So that's why I asked you when we were having that chat the other day, if you were assuming the ball Earth, where do you think the water would pour off?
I'm just saying in reality that a tool is a level tool is to establish a horizontal.
Yes, but the water at the water at point A is being pulled towards the centre of the Earth with the same gravitational equipotential as it is at sea. So it won't pour out of sea. It's not down.
It's vertical and horizontal.
Sorry?
Vertical and horizontal. Right?
I'm not quite sure what you're saying there.
If you were to drop a plumb bob at point A and a plumb bob at point C, they will both be vertical and they will both be horizontal. Now, the tool...
Hold on. They can't be vertical and horizontal. Have you misspoken there?
It would be a horizontal where that vertical is, right?
But they would be the horizontal at A would be different from the horizontal at C.
Okay, so what about the horizontal at B? Where would that be?
That would be different again. That would be different again.
So how would it be different, please?
It would be halfway in between the two.
Okay, so would the horizontal at B be parallel to the horizontal that would be established between A and C?
But the horizontal between, the line between A and C would be a chord through the Earth.
Okay, well then, at the horizontal at B, would that be parallel to the chord that you've just said between A and C?
It would be parallel to the chord, yes.
Okay, so we call one the horizontal at B that's imaginary, and you're saying that is going to be parallel to the chord at A to C, but you're saying that isn't going to be horizontal, but it is parallel to another horizontal,
though. I've got to admit, I'm getting confused with your words there.
Well, you said from A to C is a chord.
Yes.
Yes, in your imagination. Now, okay, but at B there is a horizontal, but you're saying that B won't be on the same straight line as AC.
That's right.
Okay, now you are saying that if you make a horizontal at point B, that would be parallel to AC.
Yes. And what I'm doing, I'm sorry if I sound a little vague. What I'm trying to do at the same time is I'm just really doing a quick and dirty diagram to show
Brilliant.
what I'm talking about.
But what I'm trying to say is that A to C is a horizontal and B is also a horizontal because they are on the same level. A, B, C, they're on the same tool, the same water level. There's got 3 points. Now, point A to B is also a different water level that is the same. It's a horizontal as well. It's another tool that establishes a horizontal, and that would check the centre at B with the other end at A.
Well,
Thus being another horizontal that is also on the same line.
well, my crappy diagram, and it is crappy, and I know it's crappy, is loading up now, so that perhaps we can make sure we're talking the same thing. Let me just make sure I'm looking at the right windows and see when it comes up. I've got a roughly curved Earth, and I've put our three containers on it. Okay, A, B, and C from left to right. Okay. So each of those positions, you've got. I haven't actually drawn it in. Let me quickly do it. At each of those positions, you would have a vertical, which for some reason I'm trying to do it in green. It hasn't come in green. There we go. No, go and stay in green. This bloody thing. That's that one. Every time I move it, check. Let's try another green line. So I've got three. Well, it'll take a while to come through. There are three vertical green lines. Oh, that's just coming through. Three vertical green lines, which are our verticals. Three horizontal blue lines, which are perpendicular to them. Okay. And those horizontal blue lines are at the water levels within the vials. Okay. So you've got the line across from A to C, which is your chord. B is higher, if you like, but they've all got water in them that, let's say, is exactly 1 foot above the canal or whatever you're measuring. So those three horizontals would intersect somewhere between A and B, somewhere between B and C. Okay. But they're all different.
So that's do you get that from? Where have you learned that horizontals intersect with horizontals?
Well, if they're on a curved surface such as that, they would have to, wouldn't they?
What horizontal would have to intersect? I mean,
would you accept if this is if you've got this ball Earth here, you would have three different verticals depending where you are stood on it, A, B, or C?
No, that's not how vertical works, is it?
So what would you say vertical? Let me choose another colour then. So I use
verticals established by a plumb bob. I mean,
yes,
practical, real world, right?
Yes, that's exactly what a plumb bob would do at A, B, and C.
It's not.
Absolutely,
you go and stand on a ball. See if you can get a vertical to do that.
Well, have you got a ball that's sort of 26,000 miles in circumference that I can use?
You can't do that then, is what you say.
Oh yeah, I can do it now because I'm stood on one.
You'll just imagine.
What do you mean? I just imagine?
You'll just imagine your verticals doing that when they don't actually do. In fact, you're not imagining your vertical doing that. You're imagining other people's verticals doing that, aren't you?
I see what you're saying there, because if I'm stood at A, how do I know what B and C sees?
Yeah.
But if at point A, I've got one end of that Verrazano bridge, and then at B, I've got the other tower of the Verrazano bridge, then that is where we're getting our... let me see if I can get this to... That is where we're getting our two towers there. Oh, bugger, this won't do rotation, will it? It won't rotate, so forget that. Or at least forget it manually drawn with the shape.
Have you got any geometry to back this, or are you just imagining this as being some sort of geometry, right?
Well, if you've got an Earth that's a ball
you are. You're playing imagination geometry, right?
No. Okay, we have an Earth that's a ball. I'm happy to say that. I'm trying to be fair and leave it open. What you've got is wherever you are on that entire surface, if you drop something, be that a can of Coke or a plumb bob line, it's going to leave your hand and hit the ground or dangle towards the ground vertically.
Brilliant.
Okay.
Yes.
So if you're in position
living
A,
in reality, I can do that.
Yeah. So that's what happens.
Yeah. Okay. But I did say this at the beginning. You guys go to vertical all the time, whereas I'm practical. I've studied surveying, and like we use horizontal much more. Much more.
What's the largest construction thing you've worked on then?
What?
Well, if you're surveying, is it for construction reasons?
Surveying, yeah. I've got an auto level. Yeah, my son has also looked through the auto level. We go surveying every weekend, or just down the side of the canal. We're doing a test. You might have heard about it.
Can I ask you, Bev, right, just to clarify, because this is not to knock you, but it's just to clarify, are you someone who is using some surveyor's tools and has whatever level of understanding of surveying, or are you a surveyor?
I have a surveying qualification and I have a surveying tool. My job is not surveyor. I'm a carer. Okay. So yeah,
I just trying to knock you. I'm just trying to get an understanding.
Yeah, I just have a qualification in land surveying,
right,
and some tools in order to be able to survey, and a test to establish that level is horizontal. Right? It's pretty simple. It's not, it's not. You keep going to say that you have this model, and your model dictates, and you keep saying what your model dictates.
Well, it's more than dictates. I mean, that was the evidence of the towers of that bridge. Now, I know that you're disputing it, but the evidence of the towers of that bridge are that they lean apart because they have two differing verticals.
Okay. Well, yeah, but that's why I went to horizontal. Horizontal is obviously much easier to find a horizontal than it is to find a vertical, right? You can make a longer horizontal than you can make a vertical, can't you?
Yes, but if you don't accept that a vertical for me, where I'm sat, is going to be slightly different from a vertical for you, where you're sat, then
that's just your geometry, though. You've got no geometry to support that. That's just your imagination.
Well, I've had one more super chat that's just come in from Esteban Ilabaca again for another CLP $2,500. That sounds amazing. I've got to find out what CLP is. And this is addressed to you. It says, Bev, those tools establish level at a point in the surface. As explained, the plumb will change between locations. Therefore, reciprocal zenith equals plus 180.
Okay, fantastic. I've just put a triangle in there that hopefully it might help you.
The Baller's Canal.
Yeah, that's the one.
Okay, let me just try and grab that image, put it in the right window. I'm starting to lose track. Just bear with me a second.
We'll get it up on screen first.
Yeah, that's fine.
Okay, so this came about from a conversation we had. Have you ever seen the Penrose staircase?
Oh yes, the one that was in what was that film with when they're stealing the memories from people's dreams or whatever with the spinning top thing. I can't think what it is.
Maybe.
And it's a staircase. You go up, and apparently it links up.
Okay.
Is that the thing?
Yeah. Well,
right.
Right. So
sorry, I'm trying to get this picture up for you. Let me just get that sorted.
Okay. So
right, that should be coming up for you. It's quite interesting.
Yeah.
I won't make any further comment until it comes through, and you can talk about it.
Okay. I'll wait for it. Let us know when it comes up.
Yeah, that's fair enough. I think I'm losing Windows here.
So this is something.
If you could see what I could see when I'm losing Windows. Right,
Okay.
I'm back. Yes, it's just come up.
All
The
right.
Baller's Canal.
Okie dokie. Right, so this is oh, we got a bit of a fancy colour on it there. This came about at Emma UK when we were chatting. We were talking about the Penrose staircase, and
Yep.
this came up. Right, so we've got. It's quite simple. It's a canal structure in length of 1 mile
Yep.
from A to B. So it's a equilateral canal.
Okay. Okay.
Now I would say the angles all within there would add up to 180 degrees. It
Okay.
being a triangle, right? So let's say we're on this canal and we're at point A,
Yep.
and we've got a boat.
Yep.
Now we are going to go from A to B along
Yep.
the water surface. Now I'd say that's horizontal. So we'd poodle along there, and there would
Well,
be.
I'm sure you could leave the word horizontal out anyway, because you would say it's level anyway, because of water.
Yeah, but
water
I say
sometimes
level
go
is horizontal. You say level isn't horizontal. That's why I say
Okay. You
horizontal.
carry on with your argument then. Yeah, fair
Okay,
enough.
so
Go on then.
we go from A to B. Now, I say that's horizontal. You don't. So at point B, it being a mile away, what would be the difference from the horizontal in yours, on your model?
I think that that's a malformed question, because at B you'd have your own horizontal, and that boat during every point of its journey from A to B, assuming it was a steady enough boat and you could have a plumb bob on it, would be drawing its own horizontal. There's
Okay,
no
so
problem
that
with
horizontal would be a curved line, then you're imagining that horizontal to be a
there would be an
curved.
infinite number of horizontals. There'd be one level.
Right, so can I get your definition for a line then, please? Again, geometry.
Well, I don't quite know what you're talking about. The water
Talking
is
about the
level.
geometry that you're using to describe this that you're talking
Right,
about.
that canal from A to B is absolutely straight. It does not veer to the left or to the right.
Yeah,
Okay,
it
is full of water.
Yeah.
The water is level along the entire length.
Yeah.
It's not higher or lower.
Okay.
However, that level curves. If you were to be able to, I mean, you said a mile, but
Yeah.
if it was 100 miles, it
Establish
would
a
still make no odds.
horizontal at A, because that's where we're setting off from. When we get to
Okay,
B,
you've established. Yeah, and you establish another horizontal at B. Those two horizontals would intersect at an angle, a very, very slight angle,
okay, well,
but at
let's
an angle.
extend that horizontal from A all the way to B. Then what would be the vertical distance that the water level would be away from the horizontal?
Gotcha. Well, that would be where you're roughly 8 inches.
Okay, right. So
Is.
now we're going to start from B again
Yep.
and establish a new horizontal,
Yep.
right? And then we're going to go to C.
Yep.
Again, same thing. What would be the vertical distance from that horizontal to the water at C?
That would be the same again.
Well, another
Assuming
8
your
inches.
sphere is. Assuming
Okay.
your sphere. Well, actually, yeah, it's the water, isn't it? So it would be. Yeah, it'd be exactly the same difference from A to B as it is B to C.
Right, so then we're going to go back from C now, and we're
Yep.
going to establish another horizontal and
Yep.
go back to A.
Yep.
And same again, what would be the vertical drop distance from that horizontal to the water at A?
It would be the same again.
8 inches.
Yeah, I think I know where you're going with
Okay,
this. But
so
yeah.
we've gone from A all the way round on a canal with the surface of water, and we have dropped how far? 8, 16,
We haven't dropped.
24.
Still,
well, from the horizontal, I'm saying we set a new horizontal. Yeah.
Yeah, you've got 3. I mean, you could do that in any direction, and you would have the 8-inch potential drop from the you're starting. If you called those starting points, all 3 of them, from any one of those starting points to a finishing point along one leg of that triangle, you've got your drop of about 1 inch. 8 inches. Beg your pardon.
Yeah. So
it's not an actual drop.
Turned back to you've turned back to the same point though. And it's nice of you to admit that it's not an actual drop. Yeah.
No. Well,
that's because level is horizontal.
No, because you've got 3 differing horizontals, A, B, and C.
Yeah.
But you've got one level. The water throughout that whole triangle is level
every time.
You've dropped from a horizontal.
Yeah.
But you're still at the same gravitational equipotential.
Okay, so what you're saying is you could set a horizontal at each point and go from A to B, back to A, back to B, and you'd always drop from the horizontal 8 inches every time.
Yes.
Okay. Now let's imagine we're going to go. Let's imagine we're going to go 2 miles.
Okay.
Okay. Now, would we drop more?
From your start point horizontal, yes. But you're not dropping because you're the same gravitational equipotential. That surface is level. It is the same distance from the center of the Earth throughout the entire triangle, whether it's 1 mile or 1,000 miles.
Do you think a horizontal is a tangent?
Yes, it is.
So
if you're A,
do you know where that's mentioned?
You drop your vertical. If you're A, you drop your plumb bob. You take 90 degree. You're perpendicular to it to establish your horizontal. That is, and you draw that horizontal at the level of the ground, level of the water surface or whatever. That is a tangent to the Earth. Yes.
Okay. Yeah, I've never heard anybody say that horizontal is a tangent. I mean,
right.
That's a little bit strange. That's you must be implying your model. Is it your model that dictated that for you? It's definitely not geometry, is it?
Yes, it is. Hold on a second. I'm just going to try and pull something.
Is it a tangent at the point of the circumference of the thing? Sorry,
just to let you know, images are flicking around. That's not. It's just what I'm trying to call this thing up. Just bear with me a second. Sorry. Oh, bugger.
You guys are talking about elevation. Elevation is a horizontal, right? The difference in elevation is a vertical change in between horizontals.
Difference in elevation is a vertical change.
Yeah.
Elevation is... No, hold on, what were we saying?
It's a vertical distance
going back to this
datum.
Horizontal plane is... horizontal plane through a point is a plane tangential to the level surface at that point. It's therefore perpendicular to the plumb line at that point.
Yeah, so you imagine, because you say it's tangential, that means you're implying a curved surface to level, right? That's what that actually means, because it says tangential, right? Now, a tangent is a straight line that touches a curve. Definition, yes?
Yes. And
okay, that's the geometric definition of tangential, right? What's a tangent?
Well, that's from a civil engineering blog.
Okay.
So
yeah, but you're imagining geometry again.
No, I'm not imagining.
Yes, you are. What? You are.
You've got your point. You drop your vertical. You draw the horizontal. That is a tangent to the surface.
But what's the surface? right? You're saying that the surface, because it's a tangent, then that surface, the curve that you imagine the surface of the level to be, drops away from the horizontal.
Yes, it does drop away from
Okay.
the horizontal.
So therefore, that
again,
would
we
be
got-
measured, right, with my test.
Well,
Because
if-
you can establish a horizontal,
Remember-
then you can put a water level next to it,
I
and
just
you should
realised
be
that-
able to measure that drop, right?
Well, hold on. That diagram has just come up, the one I showed a long time ago, and I just realised it's that position is sort of partway up that mountain. I know the sea's higher, but it's partway up the mountain. That's your 1,200 feet up with that water level, producing a horizontal, looking up, and therefore, because of the curve of the Earth, the sea level appears to have dropped. It doesn't rise up to it. So that was that horizon thing where we started off. So do you see what I'm saying? So if you're at that position, that's position A on your triangular canal. If I move across to where it says mean, and I dropped another vertical, which is sort of pointing from 10 o'clock to the centre of the clock, drew a horizontal, the two of them would intersect. And yet the sea level is the canal. You'd be able to sail from one to the other because it's the same level. It's the same same
You've
gravitational.
definitely got a difference there, though, on your model between level and horizontal, right?
Yes.
Okay.
Yes. That's why I keep saying level does not mean horizontal.
Okay. Well, no, that's just because you've seen that picture, right? But
No, because
what
I
I'm
haven't
saying
seen
is,
this picture when we first spoke about this yesterday.
I'm saying the horizontal being different than the level gives you a bit of a problem when the tool that you use is called a level, and it
could call it
establishes
Fred. It doesn't matter what
a
they call it.
horizontal.
So, yeah. So your tool, you could call it a horizontal finder.
Okay,
I have no
brilliant.
problem with that.
Well, that's what it is. It's
Yeah,
an auto
okay,
level.
Call it a horizontal finder.
Yeah, an auto level.
An auto horizontal finder. Then.
Yeah, that establishes
cool.
a horizontal. So, like the
Yeah.
first one in the test, you establish a horizontal. Yeah.
Right.
Okay. Then you get a water level and fill it up. Now, if
Yes.
you're at point A, you say that the level drops away from the horizontal. So at point B, a mile away, it should be 8 inches below it, shouldn't it?
Well, that's why I was asking
8
you
inches
about
below the horizontal, right?
below your initial horizontal. That's why I was asking
Well, yeah, because
you
we've
how
set
accurate was
a
those tools.
horizontal on the
Well, that's why I
tool.
was
They've
asking-
got the
That's why I
surveyors
was asking. That's why I was asking you
Yeah.
how accurate is that tool
to a millimetre.
Because, yeah, well, like I said, I didn't know how
Yeah.
accurate they are or are not. I was asking you. I'm open to learning.
So-
And you've told me that, and I've learnt something.
Right, so we get the
I'm assuming
surveyors.
you're telling me the truth.
Yeah. Well, like you can ask them. Phone the surveyors up. Over a mile, can they set 3 points? Let's say 3 points. Let's do one in the middle as well. Right? On the same horizontal. Make sure to tell them the same horizontal. Not level, horizontal. Just say 3 points on the same horizontal, right? Because then what you can do is you can get a water level and put it up to them and fill it up. Now, if you're stood at point A and you've got a horizontal there, right? You've got your man, Jesse Kozlowski, that says that water level drops from the horizontal. At point B, a mile away, you should have a drop of 8 inches, shouldn't you? From the water level, the tool. And then what you could do is then you could then go and walk to point B, and then the point at A should then be 8 inches below the horizontal.
But you know that this has been done before.
Has it?
Yeah, not using water levels, but using light. And the image is just coming up. You must have heard of this experiment. Sorry, the colours are a little bit
Well,
funny.
somebody
because
in
my
your
green
chat
screen
said
changed.
Sly Sparkane's done this.
Oh, well, I don't know about that. I don't know
Yeah,
if it's,
you want to get him
I
on,
don't
have
know
a
if
word
it's-
with it, see if he's willing to come and talk. I just need to nip the toilet.
Sorry. Oh, have you gone? Okay, he's gone for a minute, so we'll save that picture. We'll come back to that. And let's just have a quick look. I'll check for super chats because I've not been able to watch the side chat at all, which I tend to watch my streams back. I tend to watch my streams back because I do enjoy reading the chat, so I appreciate all the comments. Sarcastic Barman, thank you, Barman. Super chatted £2 saying LIGO for the win. Good point. And Esteban Ilabarca, get CLP $5,000. Woohoo! I got $10,000. I can retire. Bev, well, perhaps I better wait for that one until Bev comes back. Let's have a look at some of these comments. Where are we? Oh, there's another one coming in, so I'll have a look at those. So I hope you're enjoying this, guys. I think it's been a good... Actually, there's another super chat. Oh, right, that's still part of that. There's been, I think it's been a good discussion. I guess most of you will agree with me and disagree with Bev, but there may be some, maybe many who don't. That's fair enough. I don't have a problem with that. But for the discussion itself, a thumbs up or a thumbs down with how it's going? Oh, hello, you're back. I was just saying a thumbs up or a thumbs down. Doesn't matter whether they agree with me or you, but just how they think the debate's going, Bev, or the discussion. Because we did not organise this as a formal debate. I know I piled a whole bunch of evidence, but so I would not hold you to that anyway. Right, so let me just read the super chats because there was another one was mentioning yourself. Now you're back. So Sarcastic Barman super chat £2 and said LIGO for the win. Have you heard of LIGO?
Yeah, Xanix told us about that.
Okay. And Esteban Ilabarca has made me rich with another $5,000 CLP, saying, Bev, your interpretation and understanding of geometry is only over plane. That's not how it works over a sphere with a vector towards the center. Many examples have been shown to you. That's reality.
Okay, nice. You keep shying away from the geometry question. Do you know what he's talking about when he says that?
Hold on, let me just open it back up again because I just closed that because I was going to... In fact, let me refresh because I think another super chat's come in as well, so I've got that on the screen. One sec. Actually, a couple have just come in. When he said... Esteban said, your interpretation and understanding of geometry is only over a plane. That's not how it works over a sphere with a vector towards the center. Well, that vector towards the center is gravity. We have multiple directions of down. Yeah,
do you know which geometry he's talking about, though?
Well, I don't know is it Euclidean or whatever. I don't know. But the point is,
he's talking about a sphere, though, isn't he?
Which is what we live on.
Right. So you wouldn't be talking about Euclidean. You'd be talking spherical geometry.
And
spherical geometry is the geometry of the two-dimensional surface of a sphere, and thus has no vector. So, geometry, like I keep saying, it's pretty important. And I thought you being logic, you'd be into this sort of geometry.
Well, I would quite openly admit that I am not a mathematician. I've never hidden that. I'm not a mathematician.
Basics of logic.
Yeah, well, I've used logic in my evidence and my argument without the mathematics. I know where to draw the line with my abilities. Sorry, I'm not having a go at you, Bev, but just in general, I know where to draw the line with my abilities. There's no point in me trying to bluff something I don't know. Okay? Just like with that equipment, I asked you about the accuracy, not because I was questioning your veracity at all, but just because I didn't know and wanted to know. There is another two super chats. Hugh Jars has super chatted $5 Australian saying, ask Bev why the sun rises in the east on the equinox, no matter where you are on Earth. And Sir, I hope I say this right, Sir Pick-a-Pup the Benevolent, or Pick-a-Pup the Benevolent, super chatted £5 saying, do they know the internal angles of a triangle with side 1, 1 and 1 as their triangle diagram wasn't equilateral. I think, to be fair to Bev, that was just a diagram. I can't remember. Did you have the angles in it, written in it? I can't remember. Bev.
Yeah, do you...
I can't remember.
Does your man want to have a go of it? Because I'll say 60, 60, 60 is 180 degrees, right?
And you, of course,
geometry defines triangles to have 180 degrees.
If only you could teach Mr. Riley that.
You would agree with me, though, would you?
Yes, I'd agree with that. Yes.
That triangles always have 180 degrees?
If you're going to talk about triangles wrapped around the surface of the Earth, then you start talking something different, don't you?
I don't know. Like, I don't.
Yeah,
triangles only have 180 degrees.
Well, unless you're flying around the surface of a sphere, you go from the North Pole down to the equator, turn 90 degrees, fly a quarter of the way around the world, turn 90 degrees, and you'll end up where you started.
Right, so would you
Three
call
sides
that...
each.
Go on.
I don't know. Oh, someone else, I was going to ask you this. Call of the Void, super chatted £1.99, saying, what does £535 and a penny mean? I did notice that. There's a couple of numerical amounts on a couple of your diagrams. Is that your hourly rate, Bev?
Yeah, that's how much Jedi owes Emma from the court thing. Yeah. It's going down eventually. You'll see it ticking down bit by bit.
And so Pokepup the Benevolent, £2. Explain why geodetic surveying says it's more than 180. And I presume that's the degrees. I presume that's that triangle's wrapped around a sphere then, so Pokepup the Benevolent.
Again.
Spherical triangle doesn't have straight lines.
Yeah, so a triangle... An angle is the inclination of a straight line or plane towards another, right? You can't have an angle to a curve, can you? It's not possible. So therefore a triangle is 3 straight lines.
Triangle is 3 straight lines, yes. So if you came from the North Pole down to the equator or out to the equator and then turned 90 degrees and followed the equator quarter of the way around the world... turned towards the North Pole again, 90 degrees, and headed due north, you'd meet your start point at the North Pole. So you've got 3 sides, 2 of which are 90 degrees.
That's impossible, right?
No, absolutely not.
Yeah, it is. You can't have a triangle with more than 180 degrees.
It's wrapped around a sphere. Can you imagine?
It's not a triangle then.
What shape is it?
I don't know. It's not a triangle.
Well, it's a sort of segment of a sphere, isn't it?
A triangle is
I'm
3
not going to argue the toss
straight
about
lines.
That, but
right?
All those lines are straight.
Well, it can't have more than 180 degrees, right?
The equator, as someone's just said, the equator is a straight line, and that's 360 degrees. Because you're not turning left or right.
That would be a circle, wouldn't it? If it was 360 degrees.
Well, yeah, but perhaps we're getting a bit off topic because I did.
No, I mean this is purely what we're talking about. We're talking about geometry. You've got to have a fundamental understanding of geometry to be able to talk about what we're talking about.
Just before you ran off and so kindly didn't do an Anthony Riley on the live stream, I pulled up this diagram, which I then took away again. So it's coming up now, so you can have a look at it. Because I said someone else had basically done your
No, I came back, didn't I? I didn't
Might be
do an Anthony Riley.
No. But this image should be coming up. I don't know I can't remember who it was. I believe it was some flat Earth guys did this experiment. There it comes. It's on the screen now. Shining a light through boards with a hole the same height as the light source, and yet they couldn't see it at the far end because of the drop.
Okay, who's that? Some shills somewhere, was it?
No, it was flat earthers trying to prove that it was flat and level, and they failed.
So, like I say, I'm not a flat earther. I'm just trying to establish that level is horizontal, right?
But from that diagram, you can see you're horizontal from your start point. I know the camera's pointed at an angle, but you've got your horizontal light shining through a couple of boards. but because the surface curves at the far end, they couldn't see the light without reaching up. So there's your horizontal not matching your level.
You've not got that, like, that's not horizontal or anything there, is it? Where was the horizontal established?
Well, that's just diagrammatic. But where the camera is, or the laser, whatever the hell it is at the left, if it isn't vertical, but if you drew that as a vertical and shone the light through the first board with a hole 17 foot high, you stick another board further along the canal. So with the same size hole, also 17 foot high, so the light shines between through the two of them. You're saying that's a horizontal beam of light.
But like that looks to me like they're all vertical because they all look vertical.
Yeah.
Could that just not be a difference in the land, the drop?
No, because it was along water surface, I believe.
Oh, that orange stuff is the water, is it?
Yeah, well, that's my green screen affecting it. If I just... I'm not going to... I wonder if I can... I've got my green screen on, so the colours are coming through. It's actually... yes, let me try again, because I'd switch off that green screen.
So he's stood on water.
Hold on.
And the camera's on the water. And they put the boards on the water.
Oh, it's not letting me show you. I don't know quite why those colours are coming through as they are. Let me switch off the background. And colours seem to be coming through oddly for some reason. Maybe it's because of the way I'm picking up the images. I'm not sure.
Well, you see, what I have a problem with there is that isn't the water always meant to drop away from the person, whereas that you've got that guy, like, he's at the lowest part of it. He's the 23 feet.
Yeah, but that's just a diagram. That's just a diagram. The point was he had to reach up above his head because that's showing that.
But shouldn't the water drop away from you? Right? Isn't that what your model dictates?
Yes, that diagram is just a diagram.
Okay,
that diagram is just a diagram.
Well, the diagram's there to show that there's a big hump of water that he's having to lift his arms up to, right?
Yeah, well, it's not drawn properly. Well, Bev, hold on, let me
it's
explain.
It's higher, though.
It's not drawn properly.
Yeah, but I'm looking at 17 feet and 23 feet.
Mate. You're not letting me finish a sentence, mate. Okay. There's that diagram is showing that the light source, the boards and him all sharing the same vertical, which would not be the case. I'm not sure over what distance they did that. It's a live stream. Sorry, people, it's the live stream. It's
spinning. Yeah, I'm watching it spin.
Bugger. But maybe it'll be okay on the playback. So that's showing them all sharing the same vertical, which it wouldn't. So diagrammatically, it looks as though he's leaning forward and the camera's leaning, or the light source is leaning towards him as well. But the point was they did it along a canal or a water surface, so they had a light source that was 17 foot above the water surface, two boards a distance apart, each with holes 17 foot above the water surface. So you'd expect the light at the far end where he's got his camera to capture it, to also be 17 foot
but
above.
He's 6 foot below, right?
Yeah, it's only a diagram, mate.
Yeah, I know, but just from the numbers that are there in the diagram, what I can deduce from that is that them ones in the middle are 6 foot higher than his feet. There's a hump that's 6 foot in front of him. The water rises up 6 foot.
Well, it doesn't actually rise; it drops away at every point.
But it's not in that diagram. So what is that diagram saying? It's got numbers there that show that it rises 6 feet, but you're saying it doesn't. So no, it doesn't. Either you're imagining something that diagram isn't showing, or what is it? I mean, why does that show to you that there's a drop when there's there's a 6 foot difference?
Because it's a diagram. If you, I forget which way. So he is the light source. Actually, he's shining the torch, isn't he? In this diagram, he is not stood up straight, is he? He's leant forward. It's a diagram.
It's 23 feet. I'm just working with the numbers that we've got.
Hey, maybe he was stood on a bloody box. I don't know. The point was they had a light source and two boards with holes in, and if you shone it through, the light at a distance beyond it was not at the same height. It wouldn't show through the holes. They didn't line up because of the curve.
No, it didn't line up because he's 6 foot below.
I think it might have been Geronism who did this. It might have been Geronism, because I'm sure he said interesting when he realised he couldn't see the light shining through.
I've not seen that.
Maybe someone can let us... Oh, someone keeps getting the final 15 seconds. Hopefully, turn it off and on again. Someone's crashed. Mine's locked. I reloaded.
It just keeps spinning on the air.
What I can do is I can take a chance. I've done it before. I'm going to kill my broadcast and then bring it straight back up again. So if everyone could just bear with me, it usually will hook back up again. Let's give that a go. Fingers crossed now. Do I want to exit while live? Yes. Oh my goodness, this is always risky. Bev. Streamlabs OBS. Come on, OBS.
I'll go make a cup of tea.
Oh no, where's it gone?
So, have you studied any geometry?
Only at school level. I've got a problem here. I can't get my OBS to load. I think I have to reboot my machine quickly. Damn. Can you bear with me, Bev?
Yeah, no problem. I'm making it.
Okay, I'll just quickly reload.
I'll go over to UK. Any tips? You go in Emma UK and give us a... I think it's mainly geometry, this. It's imagined fight the flat earth geometry that most of these...
I'm back here. I'm hoping that the stream picks up again. I'm broadcasting. This sort of thing happened once before.
Oh, yeah.
Even I took trouble to reload them.
I think I can see your stream. It's back again.
Oh, they said no sound. Sound on for Bev as well. That was scary. I had to reload my machine, guys. And it's picked up the stream. Okay. So things may be a bit flaky for a while I try and get things straightened out as we carry on. Sorry, you're still here, Bev?
I am, yeah.
Good.
Are they saying there's no sound?
There wasn't when I first came back. I'll straighten that out now.
Yeah, I can hear you, but that's through Discord, isn't it?
Yeah, it is. But I can see my mic's picking up. And if you just say something, Bev, I'll just make sure your sound is...
Hello.
Yeah, that's good as well. Whew, that was a bit scary. I'm sorry, guys. I've forgotten where we were. We were talking. I think we were talking about that experiment thing. Side chat.
I was asking you if you'd done any geometry, and you said school.
At school level, yes. And I said, and I quite happily admit, I am not a mathematician. Yeah. I mean, I know where my skills lie and don't lie, and it doesn't lie with with maths. What? It's not
Well,
doing this.
see, geometry isn't really math. It's logic. It's a system
Yeah,
of you getting proof, right? Like we said the other day, geometry, the literal translation is earth measurement. So it's the practical use of logic that has developed an axiomatic system that we use to measure the earth, called geometry. And surveying is just the practical use of geometry.
That's why I was asking you when I said about construction, and you seemed a bit puzzled because, as we established, you have used some surveying equipment, and you have whatever level. And I'm not trying to cast any aspersions, but you have whatever level of training and education qualification in it. But that's what I was asking about, what size constructions. Because, for instance, if you were doing surveying to for a building, that's going to be a darn sight different than surveying for something like that bridge. Because, you know, if it's only when you get into very, very large structures that any earth curve would have to be taken into account.
What sort of scale would you put on a horizontal straight line that you would imagine?
Before you had to take that into account. I suppose it depends what you're building. If you were building a car park, then all you've got to do is get it level. If it's a humongous car park. Whereas if you're building a construction such as that bridge, where you've got tall towers and they're weight bearing and they must be vertical and so on, then you're going to have to take that sort of thing into account. But I'm not a surveyor. There may be other applications where it also has to be taken into account that I'm just not aware of.
Like you say, horizontal. If it's horizontal, then at what point would you imagine? What distance the local horizontal starts to curve? Where's the curvature of the horizontal start?
I guess technically, at any point, for instance, just across this room, there would be earth curve, but it's so small that it's probably taken up with the thickness of whatever below the carpet. It makes no difference at all.
Okay, so would that be a horizontal then? Or not? Would that be?
I'm saying you wouldn't need to take it into account.
Okay,
because
so
it's within tolerances of everything, isn't it?
Okay. So
sorry, go on, carry on.
When it says that level is a horizontal surface in dictionaries and things like that, you're just say that's like an approximation. That's not real. They don't actually mean that, do they?
Well, if I'm talking about a painting hanging on the wall, I would get it level. The top of it is horizontal. Do you know what I mean? I mean, that scale, they're basically the same thing, aren't they? But if you're talking over a mile or whatever distance, then the horizontal at either end is not going to meet head on. It's going to meet at an angle or intersect at an angle. Someone's just said, Bev, if you designed bridges, we'd be in a lot of trouble.
Why is that?
Well, that's a comment that's in there. I mean, we've said about the towers on that bridge. If they didn't have their own verticals like that, then they'd be under undue stress.
Okay, well, seeing as we're talking about bridges, I'll give you an example. Have you heard of the bridge over Lake Pontchartrain?
Oh yes.
Okay.
Well, it's not a bridge. It's a series of it's power lines, isn't it? But is that the one you mean?
Yeah, there is some power lines. The power lines were explained as how perspective compression occurs, and how perspective compression magnifies a slight curve. But that was Mick West, right? The bridge is the one that somebody took a picture of. What's he called? Stephen or something.
I
No.
don't.
There's a guy that took a picture.
The Pontchartrain Causeway. Pontchartrain Causeway.
Yeah. Right.
Okay,
So that's
let me
that's
try and
over
Google an image of it.
over the lake. Right.
Right.
So that goes over water surface, right? Now, you start at one edge of the bridge. I think there's a surveyor put a thing on his roof of his car and drove over it.
Right.
Right. So, the point, let's say point A and point C is all the way across, right?
Yep.
Imagine it's like my water level.
Yes.
And then point B in the middle would be higher?
Middle. Well, this is it. What do you mean?
Because
higher?
you have to call A to C the chord, right?
Okay. Yeah.
You would call that a chord. So then the other bit the bit at B would be called a secant.
Yes. So that's your hump, if you like.
Right. So
But
that is
reality,
higher, right? It's
each
higher
end is
than the
20
chord.
Yeah, the higher than the chord, but from the water surface, each of those points is perhaps exactly 20 feet.
Sorry.
Well, because the water curves, if point A and point C, for the sake of argument, are 20 foot above the level of the water.
Well, no,
okay?
they are the level of the water. That's what we're saying, right?
All right. Okay. So their elevation is 0 feet above the water level.
Yeah, that is the water level.
0 feet above the water level at C. Sorry,
yeah.
But it's also 0 feet above the water level at B.
Well, Jesse Kozlowski, one of your top surveyor guys, the one that said that the water level drops away from the horizontal at a rate of 8 inches per mile squared. Well, he drove over that bridge with a piece of equipment on his roof, and he put that secant. Well, actually, he gave them coordinates and all of that stuff to Walter Bislin, and Walter Bislin made a model, and that model has the secant at 28.5 meters. From that on that Lake Pontchartrain bridge right in the middle. So he's got a hump of 28 or 24 maybe, I think.
You do know from what let me get this. I've got an image up, or getting an image up. It's a bit slow. Oh, come on. Let me try that again. Image. View image. Right. Okay. Let me try and pull this image in now. Pop, pop, pom. Okay. This apparently is the Lake Pontchartrain Causeway. It actually rises towards the middle anyway. Assuming I'm looking at the right one. But this did say Lake Pontchartrain. But since I've never seen it before.
Oh, you mean the bit for the There's I think there's 3 or 4 humps where they have to get for the boats to go under.
Yeah.
So
I don't.
No, that's not. No. The one that Jesse Kozlowski did when he put the equipment on the roof of his car and drove over it, and gave that to Walter Bislin to make the model. Well, the model that Walter Bislin made has the water level as 20. That secant 20. I'm having a look now for it. I think it was either 24 or 28 meters, 28.5 meters above.
Just out of interest, because this whole thing is not something I've even heard of. I didn't even know that there was this causeway before you mentioned it.
Right.
Do you know how? Well, I've looked at the transmission lines before because that's come up a lot. Do you happen to know? Or roughly know how long that causeway is?
It's about 20 odd miles or something, isn't it? 23, 24
Oh, right,
miles,
so it's pretty long.
Yeah, which makes that hump in the middle. That's why they imagined that where they made the model to have that 24.5 metre hump in the middle, because it has to, because of your model dictates that when you get further apart, then that secant gets higher.
Absolutely. So if I don't, and this is not anything to do with my maths, but but bearing in mind the distance you're talking about, sorry, did you say about 20 miles?
Yeah, 23, I think. 23.
Okay.
24
23 miles. I mean, I won't hold you to an exact figure, but 20 odd miles, then, yeah, you'd expect a reasonable amount of curvature. What that is and what secant that would produce, I don't know. I've got a couple more super chats. One from Macabre Malefica for $5 Australian, saying, could we stop platforming Bev? His whole shtick can be summated as no two arbitrary points can be relative to one another. And Call of the Void.
Can you explain what that means?
Hey, it's not my comment. I'll read it back again so you can have a... Could we stop platforming Bev? His whole shtick can be summated as no two arbitrary points can be relative to one another. You'll have to take it up with Macabre.
Yeah. Does it make any sense to you? Because it obviously makes sense to Macabre, right? But, I mean, if you just bypass it now, he'll think it's me that doesn't understand it, whereas you can just bypass it and pretend.
I see what you're saying. I see what you're saying, but I'm not sure which point he's addressing. Are you addressing, Macabre, are you addressing the business of the every vertical being different around a sphere?
He's saying my whole stick, so, I mean, relate that as what you want, but...
Well, I'll tell you what.
These sort of comments happen a lot, right? So could you just base it around what my entire stick is? Have a go at.
Sorry, you're talking to me, Bev, or to Macabre?
Yeah. No, I'm talking to you. Like, what do you imagine as my entire stick? Because
okay. I would put it as you not accepting that level is not the same as horizontal, and that verticals on every point around the Earth are not parallel to one another.
Okay, right. Well, I'll tell you that my stick then is based on Euclidean geometry. It has a very firm understanding of it. At least I do. So my entire stick being based around geometry and the logic behind that is brilliant. Thank you very much. Yeah. If that's what you imagine needs to be deplatformed, then hey.
I'm not trying to deplatform. I'm happy.
No, and I'm saying he's paying you so you can say that though.
Well, it's a super chat, and
yeah.
It's arguing against you, but it's not being abusive. If it was one that was just abusive, calling you names, to be honest, if someone super chatted that, I'd say thank you very much for the money, but I'm not reading it out. Okay, because I don't do abuse. Okay, Bev.
Okay,
but yeah, if someone disagrees.
I didn't say you were doing abuse.
No. I know you're not. But if someone put a super chat and argued against something I said, I would read that out as well.
Mm-hmm.
So, Bev, by all means, do a super chat. Pay me some money and I'll read it out. Call of the Void, a super chat of £1.99, saying, at Slim, living cyborgs plums on my horizontal. Okay, cool. No, I'm really not sure what that one means. I'm not sure if that's attack on me, attack on you, Bev, or someone else.
It sounds like one of your fans, that.
Okay. Well, there we go. So that's the super chats, I think, up to date. So you're talking about this causeway. So about 20 miles long. So what does that give? 8 inches per mile squared. Can anyone quickly do the maths?
That will be a drop over the entire distance.
Yeah, but then
then you've got a rise, though, haven't you, on the model? That was what I was pointing out.
Well, it's not that it rises from.
It's a secant of that.
Yeah, exactly. So if you look horizontal from A,
so whilst dropping away from the horizontal, it rises. Sorry? Whilst dropping away.
No. If you're stood at point A, you take your vertical, you take your horizontal, then that 8 inches per mile, roughly, will give you the drop to B at the other end. If you're stood at the other end, you do the same, you'd have a drop of the same amount to A. Because that you're looking, you're always stood in effect at the top of the ball, so everything drops away from you. If you looked from A to B along the chord, which is not perpendicular to your vertical, then you've got your secant, you've got your hump.
Okay, so you do have a rise, but the rise isn't a rise, it's always a drop. It just depends at which way you look at it from.
Yes, yeah, absolutely. It depends which way you look at it. So if you've got
this is geometry, right? It's like real life practical geometry that you can't just look at it a bit differently and get it to change.
No. We're talking conceptually, because if you were actually stood at A, you wouldn't look through the chord, would you? You would just be looking forward as horizontal as you could, and it would appear to drop. But conceptually, if you could draw a straight line from your eyes from A to B, then a hump would be rising in front of you. But you wouldn't be doing that. That's looking down towards the surface of the water.
The level of the water is horizontal.
And we're back where we started again.
Yeah, because that's what it is, right? The tool that we are setting up, right, this test, can you understand that when you say the horizontal, like, are you willing to give a surveyor the ability to establish a horizontal line?
What do you mean, am I willing to give them the ability?
Well, there are surveyors, you will give us that there are people in reality that have a job, and that job is called surveying, and they use tools right now.
But of course, yes.
These people, now over 1 mile, these people can establish a horizontal reference. Right? Okay. So that is definitely possible in reality with people that have jobs to do that.
Well, I would believe so. But actually, going back to your test, because this was something I was thinking about earlier when we got either caught up or whatever. You know, go back to your thing when you've surveyed your horizontal from A along the canal to B, and then you strung your water level thing, and you've got a midpoint as well. I think I would be predicting that what you've done with that horizontal is, well, I was going to say you have drawn the chord from A to B. I'm not 100% sure of that now, but I would expect that. But forget that, because I think I was just talking at my arse then. But I would, if you were to do that that experiment which I showed you with the light and the boards. At the midpoint, if you've got a three-way water level all strung together, pretty much like your photograph that we saw earlier, then the water at the midpoint would be higher, for want of a better word, than the two endpoints. They're all level, of course, because it's the same body of water, but you could not draw an exact horizontal line from A to B through C in the middle. On the surface of the water in your 3 vials. Do you see what I mean?
Well, like I say, we've got 3 points. If we establish 3 points on the horizontal, you've got A, B, and C, right? Like if we go back to my test, they're B in the middle and C. Now, when they're setting that horizontal, they can mark those 3 points. And then when we put our water level together, we can fix it to those 3 points, can't we? And then just fill the water up within the water, within the tubes. I mean, that you would imagine that's not too difficult a task for anybody to do, right?
And do you know what? When we were talking about this, and I won't mention, because I don't believe in doxing or anything like that, you did mention an area of the country where you're looking to do this. Have you any idea when, and are you open to a visitor joining and watching?
Yeah, of course. I mean, like when we do this, right, we're going to invite people because
Well,
obviously the only point of interest that anybody could really have a problem with is the horizontal, right? Because nobody's going to deny that we can't fill a tube up with water, right?
no. And
No, I mean that's easy, right? All you've got to do is lay all the tubes out together and get them in the right arrangement, put the vials together, and then fill them up. Right? It's not hard.
I would certainly be open to that, assuming work commitments and so on. I would be open to doing that. I'd be open to documenting it fairly, and if it would be interesting to see if I would be able to turn around and say, "Aha! I told you so," or, "Do you know what? That is odd. I can't explain it." Mm-hmm. I am open and honest enough to do that. Actually, someone put a thing in the super chat saying they dropped me an image, which actually is going to be very small. Let me see if I can resize that a bit, because I don't know if it will show up otherwise. Drop me an image of a newspaper clipping, and I do apologise because off the top of my head I can't remember who dropped the link. It is just coming up now. Oh, I've turned my camera off, otherwise I'm right. It's about the 24-mile Causeway Bridge when it was near finished in South Overlake Lake Pontchartrain, and there's a little highlighted bit in there, and it may be hard to read on screen, so if you can't read it, people have to look at it on my Discord or whatever. But that highlighted box says, because of the Earth's curvature, the structure will be 2 inches longer at deck level than at the waterline. Provisions for expansion and contraction alone require an additional allowance. Well, of course they would, yeah. But
wow.
Yeah, so because
2 inches, and it goes 24.5 meters or 28. I was just looking for that to find out
miles. Well, it says 24-mile causeway.
Yeah, that's how long it is. I'm saying it rises up, according to Jesse Kozlowski and Walter Bislin, the one that made the model for it, that has the secant, the rise of 24.5 meters. That only adds to 2 inches.
No,
wow.
No, you're misunderstanding, because with that rise that you're talking about, for want of a better expression, the bulge in the water, aren't you? Well, this is saying that the bulge in the water would follow a perfect sphere. The causeway, I don't know how high above the surface of the water it is, whatever it is.
It was about 5.7 all the way along.
What, height-wise, above the water
about
surface?
5.7, 5.8 metres all the way along.
What that cutting is
a bit of a straight line, really.
Because that is, in effect, drawing a larger circle, it's 2 inches longer than if you travelled on the water surface. But there we go. I mean, you can argue that, but that's just a newspaper clipping. It's quite interesting.
Are you going to use that as one of your bits of evidence for the water curving? Does that add to your willingness to say that level isn't horizontal?
I don't need to add to my willingness. I'm 100% on the fact that level does not mean horizontal.
Okay.
So that does. But
would you say that somebody who says that level is horizontal, that implies flat Earth?
Yes, I would. I mean, I know you've called yourself a leveler, and I'm not going to knock what you call yourself, although I must admit I find it hard to understand what the difference is, because you said about geography, but I mean, I think that's a given on either a ball
geometry, I think I would have said.
Well, with mountains and stuff we were talking about.
Yeah, topography.
Topography, yes. So I think that's a given. Whether you're talking a ball, we still got mountains, so it's not a perfect sphere, or a flat Earth, you still got mountains. It wouldn't be a perfect flat, but there's still a massive difference between a flat Earth and
so
a spherical Earth.
the curvature would have to be found within the water level, right? Because obviously you can't find it on the land because of the topography. So the only place you are ever going to find any curvature that you're particularly looking for would be within the water level.
That would certainly be the best and easiest place to look for it, because you've got things like
best place to look for
flats,
that would be within a canal, right? Because a canal is a locked body of water in between from one lock to the other. That is
you've not got waves and stuff.
Not much on a canal, no.
Yeah, which is why they chose that for the Bedford level experiment.
Right. Yeah, so that would be the place. If you were looking for curvature, you would be better to find it with a long body of water.
Yes.
Yeah, that's why I chose the water level as the test, and we can combine that with the surveyors that survey the horizontal.
Well, the beauty about your water level is there's no, because it is the perfect tool for establishing level. The beauty of it is there are no moving parts, there's no electronics or anything like that. All it's doing is relying on gravity. As I said, the gravitational equipotential, which is the same across the whole body of water.
Yeah.
So that is perfect.
Yeah. Okay, so it's perpendicular at every point along the surface.
Yes. So if you've got if your water level consists of A, B, and C, each one of those will be how to explain it.
So it's it's perpendicular.
Well, I think we're going to cover the same ground. You'd have three horizontals, I'm about to say.
Yeah.
But they would all. I mean, to be honest, either flat or curved, flat or spherical Earth. Those 3 points will be level. Not necessarily in a straight line, but they'll be level. Because on a flat surface, it's what you're talking about. They would all be level and horizontal to each other. On a spherical surface, they'd all be level, but different horizontals.
Okay, but
so level itself is not a problem. We agree on that, I think. When
you say you're quite willing to say perpendicular at every point, right?
Yeah, I'm talking about across. Yeah, we're talking about.
But that's where we have to go back to Euclidean geometry, right? That is where we use the definition, or we get the definition for perpendicular. And a perpendicular is a relationship of one straight line to another at right angles.
And that's where we get back to the fact that at every point you've got a different vertical. So you're getting so you have a different perpendicular, a different horizontal to each of those verticals.
Sorry.
Well, if you're talking about along the length of your canal, A, B, and C, each one you drop a plumb line, you are going to get a vertical. Those three verticals will differ from each other. Therefore, each of those, using whatever tool to establish a perpendicular to that vertical, will give you a different horizontal. Okay,
so when I
Which is where we came in, isn't it?
Yeah, well, when I use a tool, the auto level, right, and I can look, like say I look one way 50 meters, and I can then turn and look the other way 50 meters. That 100 meter line that I've just made there, that would be considered a horizontal, wouldn't it?
Well, you marked it outside. Perhaps you burnt it in with a laser, or you got a laser flicking around. That is a horizontal plane you have drawn.
Yeah, because I've measured it. I've actually measured a point at one side, above. Let's say it's the canal water level, and I've got an auto level at the side of the canal. Now, at 50 meters away, I can put my level in and mark that, and mark a height above the water level, right? And then spin it round 180 degrees, look in the opposite direction, and mark that height above the water level, right? Now, those two, the the sight line that I've looked through my auto level with the crosshairs, they have a horizontal hair in the middle. Now that has been the same horizontal from the left to the right. It's the same horizontal plane that I'm marking, right, and measuring.
Yes.
Okay, now let's come back as well and do 25 meters.
What
right?
distance?
And, yeah, as well as the 50 meters. This is called double rodding. Right? So we are now measuring 2 points on either side.
Okay.
Right. Now, then when we traverse and we move our auto level, because we have to chain all of these measurements together, then when we look back and the 25 and the 50 and we mark them again, measure them, they will be on the same horizontal plane, won't they? Or would you imagine that there is some deviance over those two measurements?
Because if we assume that it's a perfectly smooth surface, whatever the shape of the surface, it's a perfectly smooth surface. You've got no topography, okay? I would expect that there would be a deviation. However, over those sort of distances, it'd be so small, it's probably within any margin of area that you could measure with that equipment. Because what I would expect is when you started off and you drew your 100 meters at each end, let's say the height of your equipment that you're drawing your horizontal from is exactly 1 meter, then I would expect if you then go to each end where you sent a mark, it to be fractionally higher than a meter. In effect, you were stood on the bulge. You were stood at the top of that secant.
Okay.
I've actually got a few more super chats flowed in from Esteban Ilabaca for CLP $2,500 again. Bev, let's make this simple. Your interpretation of level is for Euclidean geometry. You need to accept that level also applies to non-Euclidean (spherical). Call of the Void super chatted £1.99. Mage version 2. Do you know about Mage? Did I mention Mage, my balloon?
Yeah,
you, Bev? Yeah. So I'm setting up a weather balloon with a camera to try and photograph the curve of the Earth. So that'd be interesting. Jessica G super chatted $2. I'm afraid this is against you. Bev debunking himself one argument at a time. And Cajun Drifter, $10 US, soundly did an in-depth analysis of the Pontchartrain Causeway. It's 26. Okay, soundly then. It's 26 miles long, brackets longest in the world. I have lived near the causeway for several decades and crossed it many times. Well, that's really interesting, Cajun. Perhaps you should do a video about it and, let us all know some more information if you're in the vicinity. Certainly from that photo I see, it's an amazing structure. Absolutely astonishing.
Yeah, we have Rick here. He goes over it all the time. Takes loads of pictures of it.
It's amazing, isn't it?
Yeah, it's amazingly
I wonder how much something like that cost.
Horizontal.
Oh dear. Actually, someone did put a comment, and it's quite an interesting one, about your experiment test, or however you want to phrase it, that whatever it may show...
Sounds nice. Do you know how to make it an experiment?
Well, what I'm saying is that they said that whatever it shows, you're not going to be disproving a sphere with it. Do you know, I genuinely would love to come along to that. I really would. Not a case of coming along to point and laugh and take the piss. Not at all. But because whether you're right or wrong, at least you're trying. Same with me with my Mage. Whether I send it up and like the last attempt, it didn't work because we had a manufacturing fault. But whether it fails or goes up there and produces an indeterminate result, at least I've tried. And you're trying with this, so props to you for that, honestly.
Okay, so what was that then? He doesn't... What was that?
Sorry?
Because that was some sort of criticism. What did he say?
Well, he was saying it won't it won't disprove the sphere. I think. Let me see if I can find the comment. I'm going back a bit.
It's the difference between a straight line and a curve, or a straight line and a tilt.
I don't know,
Because I mean, level doesn't tilt, does it?
Sorry, I'm not quite sure what you're saying. If you're following a water surface and you're 1 meter above, and you maintain 1 meter above, as that water surface is curving, you're still at a level of 1 meter above the water surface.
We have a quite a good one at the minute that goes, how do you measure a curve? How would you imagine that you would measure a curve? Because all the tools are measuring point to point, right? That if you imagine a theodolite measuring something, he's measuring a vertical distance above a certain point, right, to the horizontal that is established through the line of sight of the thing. So that's a point, and then you can go and measure another point and another point, but the best you can do is mark those point to point. How do you measure a curve? I give it to you that you can't measure a curve with a theodolite or auto level.
See, with your surveyors, with your, I think it's your first diagram showing them measure in a chain, or however you want to term it.
Differential leveling.
Yeah. Actually, I think that was mentioned on one of those links I had as well, or it was something leveling. But I'm wondering how much that's affected by the shape of the Earth. I don't know. That someone else has super chatted. B-Ball for Life actually asked me to show you a photograph, so let me pull it up.
Has he got?
And sorry about the green screen; it's really affecting things. Oh man, that's really screwing things. Let me just try and turn off the background video as well, because the colour's all funny. I don't know if it's my green screen because my camera's off. Well, let me transition it anyway. We'll give it a best shot. It says, ask Bev if the water is level with the beach or with the bottom of the ship in this picture. So the colours are funny, but I think the image, when it comes through, is going to be okay. So give it a chance to come through. And I'll just wait for that. I'll see if there's any other super chats there.
Wow, that looks pretty bad. Has he got?
Yeah. The colours are funny. Perhaps you can have a look at it in the Discord. It's in general chat.
Has he been to the beach?
It's not my photo. It's not my photo. It says it's a distance of 25.3 kilometres. Observer height is 2.4 metres. So that's B-Ball for Life, $2 US. Thanks for that, B-Ball.
Yeah, that's
Saying
nice.
Dropped an image and a question for Bev in Discord. King Crew, super chat $2 US, saying, can you please make
Lovely
Geist
picture.
View a mod? Well, King, sorry, I got my own internal, personal and private decisions.
He'll be
and
after
rules.
trying to kick us.
No, I decide who I make a mod. Some people wait longer than others. I did actually make a couple of mods tonight. One of them's Chris Durham Music Channel. I mod people when I'm ready to mod people. Okay. And actually, if I may just take this chance, I'll quickly give a quick shout out to all my patrons. So we're just muted just for a second, Bev, okay?
All right.
And thank you for this. It's been, I've really enjoyed this. I hope you have too, mate.
No problem. I don't think you quite understand the geometry behind it.
All right, hold on a sec, it's just coming back. And we're almost back again. Where's my camera? There's my camera. Oh, I got the photo as well. Oh, blimey. I've got sound. Yeah, I've got sound. Sorry, what were you just saying there, Bev?
I said I think you're missing the geometry, the beauty of the geometry behind this. Massively. You're big on the logic, but I think you should look into the geometry.
Well, I can try and look into some stuff, but it's still going to come back to what I would consider reality, and evidences like those towers of the whatever it's called, Varazona Bridge. I can't remember the name of it. I could barely say it even when I had it in front of me. Yeah, but look, it's coming up to midnight, and I did just say to Bev just while the Patreon reel was running that I have really enjoyed this chat. We've obviously disagreed a lot. We've covered a lot, but I think we've done it in a polite manner and respectful manner both ways. Hopefully, you'll agree with that, Bev.
Yeah.
Cool.
I'm always
cool.
like, we're open for this sort of discussion all the time.
That's brilliant.
There's
stuff.
Loads of people who are not brave enough to come and chat.
Yeah. Well, hopefully, you can mention to other people on your side that give people a fair shout, and I don't shout over you, mute you, boot you, just because you disagree or you show something that stumps me for a minute. I want to learn. I mean, obviously, I'm pretty sure on my position, but then you are too, and that's where the interesting chat comes, I think. Oh, Channel Rights just super chatted £2 for Mage 2. Thank you. Keep up the good work, Mr. Sensible. Thumbs up. Appreciate that. So listen, Bev, like I said, I think it's been good. Maybe you'd like to do it again sometime?
Well, yeah, like we were always up for that discussion.
Okay.
I'd like to know where you get your curve from, other than just imagination. Somebody's told you to.
Well, I'll tell you what, Bev. Why don't we wait until after I've sent up Mage 2 and I've got photographs of either the flat or the curve? Then we'll have something to talk about, because like I say, that's where I got my curve from.
Optical.
Well, every single one distorts in the same way. Well, let's see. I mean, hey, we got up to 5,287 meters last time, which ain't high enough for anything. I was quite honest and open about it. It also cost me a bloody camera, 150 quid, because it came back down again with the balloon partially inflated. So when it landed, it didn't just land with the parachute and stop. It then dragged across a field and bashed through hedges, and we lost the camera. So hopefully we're not going to get that sort of fiasco again. But like you with your test, having a go at it. And I think more power to you and to me. It'd be good if more people did it. We got Blue Marble Science doing his Cavendish experiment. Because, I mean, hey, he can do his experiment. You can disagree with the results or argue the toss with the results if you want to, but at least he's done the experiment. Whereas there's certain other people who shall remain nameless who just shout and blather, but they're not putting their money where their mouth is. They're not going out and doing a test or experiment like you or I. So I don't think they have any right to criticise.
We've done it for zero cost to anybody as well.
Yeah, good stuff. I mean, there are physical costs involved in mine, just for the gas, for instance, and
there is for us as well. But we don't want to make anybody. We don't see why anybody should have to pay for what is known as a normal fact, right?
Yeah, with mine, I was perfectly willing to pay for it. I was expecting to stump up, I think it was around £600 was my estimate, and this would now be the second attempt, plus a camera. But very kindly, people have made donations. I didn't ask for those donations. They were gratefully accepted, and it certainly meant that I can try it again. So thank you to patrons, members, those who've donated. And I actually had, and this was without any asking Bev, I've had 3 people, Bob the Science Guy, Arctic Haze, and a guy who does rigging for hang gliders and things called Just Shoot Me, which is a brilliant name, from Canberra, Australia, who asked and offered to help sponsor it. So, I have not asked for a penny. I have been given money to cover it, which is immensely kind.
That's nice.
But if you've managed to, yeah, it is. Okay, well, listen, I'll tell you what, Bev. Please do give me a shout nearer the time, and I will endeavour to come along. I would like that, and perhaps not just meet you, but meet some of the others. and we perhaps have some interesting conversations.
Well, yeah.
With
Yeah,
no
yeah.
doxing.
Yeah, well,
Cool.
have a look into some geometry, and you should have a better understanding of how horizontals can't intersect, and that's geometric proof.
Well, I tell you. Oh, and just saying that, this Mike71's just donated $5 US. Here's for Mage 2. Thank you very much, Mike. See, just like that. Well, Bev, I'll tell you what, if you've got some links to something you think might be useful for me to read, please chuck them my way and I'll have a look.
It's called The Elements. Look into it.
The Elements.
Yeah.
Okay. Is that a particular author?
Euclid.
Okay. That one.
Yeah.
All right, mate. Listen, spot on. I've really enjoyed tonight. So I would like to thank you for coming and thank you for being a good sport in the face of some of those super chats, mate. Okay?
Okay.
Cool.
No
and we'll do it again, yeah?
Yeah.
All right. I'll say thank you very much. Everybody, tonight I'm going to try not to make a mistake and I'll put the proper outro on because the last couple of live streams I've managed to screw it up. So I'm going to say thank you all very much for coming. Appreciate all the donations, super chats, my members, the sponsors and everyone. Hope you've had a good time. I have. I've enjoyed it with Bev and we'll do it again sometime. Until then, take care and stay sensible. Cool, we're clear, mate. Thank you very much.
No problem.
Yeah, genuinely have enjoyed that. I think we do much more, and we get through more stuff, more arguments, by talking politely as we have to each other. Well, I mean, I could call you names, you could shout names back. It's a waste of time. It's just a slagging match. No one gets anywhere.
We don't work like that. Never have, never will.
No, and I know that certainly from the taster on Emma UK's. Yeah. That's good. I'm all for that. I really am.
Yeah, well, I mean, I'd like to commend you because there's a lot of people that are running from this discussion because, like I say, that you do not have any geometrical backing for whatever you say. You just have an imagined curve. And just look for in the geometry and find if you can find some proof within the geometry. Because there's none of your side in particular that will want to talk about this geometry. They want to go to non-Euclidean geometry in order to explain this, and that non-Euclidean geometry does not explain this.
Well, I shall have a look. Like I said, I'm not a mathematician. I shall try and read some of that stuff and see where I get to with it, okay?
Well, you do say logic, right? And you have to come at it from a logical point of view because it teaches you logic.
Well, it'd be interesting stuff, wouldn't it?
Yeah.
And yeah, absolutely. I mean it. If you and whoever else is with you is open to myself coming, I would gladly do that. As I hope I've made clear, I don't believe in doxing. So if I turned up and for instance, I don't know if you ever appear on camera, Bev. I know some people do, some people don't. But if you were someone who doesn't, I wouldn't dream of taking a photo of you and showing people. Do you know what I mean? I just do not believe in that side of things.
No. So, we go testing every weekend out by the canal with the auto level. We've got an arrangement that we can put a camera on it and we can put the pictures and the live stream straight into the Discord. So we do that live at the over the weekend. So yeah, we're quite often on camera.
Okay.
There's no problem.
Look, in the live waiting room, there's two people, Demon Orb and Glass Monster. I don't know if you want to go in there and chat or just want to clear off.
Is that what they're waiting there for? Are they after
so that live waiting room? That live waiting room is a room where people who want to guest on the show get pulled in from. So by appearing there, I could drag them onto live. That's the risk they take.
Okay.
What I would typically do, typically there's a up to, I don't know, maybe 8 to 10 people at the end of the show, and whoever my guests are, we drop back in there and chat. But having said that, it's quite late, so I'm probably not going to hang around for long. But if you wanted to jump in, then you're welcome to stay. The other advantage is you can go out of there and come back into there. If you go out of this room, you can't get back in because it's locked.
Yeah,
Okay.
yeah. If we're off, we're done here now. But I mean, again, if people are willing to talk, I'll go and nip in there.
All right, I'll hop in there with you as well, just to say hello, but I won't hang around for long. All right, mate?
Okie dokie. All right.
Okay, thank you. Right, let's go. Hello, guys.
Hey,
There he
how you
is.
doing?
How's it going? Did you enjoy the stream?
Yeah, different.
It was muted the whole time.
Yeah,
Only
right.
joking.
Bev, it's something that happens to me quite often at the start of the show, or I show a video and I mute myself and then forget to unmute. The toe rags are always winding me up.
Yeah.
Nice.
The yeah.
So I'll
Oh,
be
by the way,
back in 1 second.
plan on making the flight again.
Hello.
Yo.
I've been plan on making the flight again
Oh, do you? When's that going to be then, Glass?
in the spring.
Okay. Yeah, we were
Yeah.
supposed to be doing it again, sort of, well, about now, but the weather's shite.
Yeah. I took
No.
I put her in a box and froze her down to about 60 below. And I was able to get 5 hours battery life. So I said, that's good.
5 hours is good, isn't it?
Alkaline batteries.
Sorry, I'm grabbing something to eat.
Yeah.
Apologies.
Alkaline batteries. They're soldered in. They're not in battery holders. Battery holders have weight.
Everything has weight, doesn't it?
No,
Yeah,
that's a problem with gravity.
Bev, just so you know, Glass is putting up a weather balloon as well. Or didn't you?
If it went up, flew perfectly, did all the movements of it, no camera. Yeah, I've completely redesigned my fuselage. It is still a glider. It's going to be a glider. From the distance, it doesn't look any much difference. It's gained a slight amount of weight. I'm going to be sending it up with it in the gliding position instead of hung by the nose. And the two cameras will be in the nose.
Have you got any film of your previous flight?
No, just noise.
Or photographs of the equipment or anything?
Once I have a successful flight, I'm gonna have some film.
Okay.
I'm one that if it don't succeed, I don't film. Whoops. But I plan on, like, on its way back, it took it well in excess of an hour to get back home. It was up so high.
Oh,
I made it to full height. I actually did get to full height. The balloon did not pop.
yeah, well, ours travelled about 30 miles. I think it was 30 miles.
Yeah.
And our last predictions for sort of today and tomorrow, because of the wind, put it right across the country and out to sea again. So we've drawn a line under it for this launch window. And
Yeah.
we're waiting for Saturday the 3rd to the 6th and try that.
Yeah.
Because after that, I got 13th to the 26th, so a 2-week period because I'm on leave. So hopefully we'll get it during that, if not before.
Yeah. No.
That was major windy today.
It's way too much dreaming.
What do you think of that? You first.
No, I didn't hear what you said.
I said, what do you think of the idea of the payload being a glider?
Well, it's a different thing you're trying to do with it, isn't it? I have seen someone
Exact
else.
same thing. You're doing
Well,
going
I've
up
seen-
to the earth.
I've seen someone else drop a glider from a hot air balloon. There is a YouTube video of it. Hello, Mark.
Mark is muted. Yeah, no, I was thinking that by you doing a glider, I have a lot more predictability exactly where it's going to hit the ground. You know
Well,
what I
you
mean?
said that you're not relying on the balloon popping.
Sorry,
No.
hello.
Hello,
I'm
how are
not
you,
rely-
Mark?
I'm
Not bad, you?
Holy
Yeah,
cow.
all right, thanks, pal. Thank you. Did you enjoy this stream?
Very much so, yes.
Well, we've still got Bev in here with us, and I think he's open to chatting.
I know, I see that. Yeah. I've been wanting to ask you about this contraption for a while, sensible. That's why I've been anxious.
Sorry, Bean, wanting to ask me about what?
Oh, my project and your project. Yeah.
Well, I would like to see photos. If excuse me, if you've got any photos of it, if you don't want to share them to others, you can always DM me. It'd be interesting to look at them. I wouldn't share them, obviously.
Yeah. Once she comes down again,
Yeah.
Buddy's going to chase it with his airplane and show the thing in flight.
Oh wow. Well, that would make some good.
He's going to follow it with his RC airplane. He's got an airplane that can stay in the air for near an hour. So he's going to follow it. So he would have no problem catching it because it's a glider. But yeah, GPS to get me somewhat close to me, and then handheld RC remote to bring it right to me. So I'll be able to see where it's going. You know what I mean?
Is it only you tracking it though?
Huh?
Is it only you tracking it?
Well, I'll be tracking it, and so a friend of mine be tracking it.
Okay.
But because it's going to be leaving the balloon in flight position, it's going to be doing its balloon ride in flight position. I won't have to worry about the GPS pointing it.
Excuse me. Yeah.
That was one of the concerns you had, wasn't it?
Was what?
Is the thing having a problem with the GPS?
You can measure this. The level surface drops away, drops down from the horizontal plane,
the cell
at
system,
a rate of 8 inches times the distance in miles squared.
Yeah,
you can measure this. Oh, yeah, it's measurable. The level surface. You can measure this. Have you tried measuring this? Oh, yeah, it's measurable. The level surface drops away, drops down. Oh, yes, measurable.
Or upside
from
down.
the horizontal plane, drops away, drops down.
With the
Have you
cell phone,
tried measuring
you're
this?
reliant
You
on
can measure this. Oh, yeah, it's measurable. You can measure this. Have you tried measuring
within
this?
a few
I did
hundred
not
meters
say
of the ground,
that the
way
level
up, it
is
won't
not
get it.
horizontal.
And also landing or going into an area where there's cell phone coverage at all.
Autistic child is
Because if there isn't, and excuse me, guys, if there isn't, then you're just not going to get
you
tracking
teach your
on
child
it.
that level
Whereas
is a
the
horizontal
GPS,
plane, which is not true.
It follows
and
it
the implication
down
of that
to
is that you are
a few
teaching your
hundred
child
feet.
here if it's
But
flat.
there are a lot of people around the country who would be tracking it at the same time. So we're going to get the data that gets you close to it. Then it's a case of hunting with an aerial, and actually narrowing down the area.
Yeah. Okay. In my case,
Or like last time, driving along the road and see it strung across the road in front of you.
In my case, like I said, mine's going to be basically a small aircraft. It's going to go up in flight position, and then when the time runs out, the magnet shuts off, balloon goes away, plane falls. Simple as that. And yes, I've already took the thing up several times and dropped it, and it is dropping perfectly.
Good. Well, I'm glad.
In fact, I've dropped it 50 times.
Hey,
so I'm testing out the hardware close to the ground, so I can find the thing again.
Yeah, Bev. If you see a few rooms below, there's a room called Enemy Intel.
Yeah.
Videos. There's a link in there from Phuket Word, Flat Earth versus How Surveyors See Imaginary Curvature. I haven't looked at it yet, but that might be quite topical, bearing in mind what we were talking about tonight. I don't know what he's going to come up with. I have no idea. Well, looking at the diagram...
Yeah, the imaginary curvature would be the curvature that you're imagining.
And
Does anybody know what theodolites are?
Well,
since we're now going over to flat Earth.
What?
Well, just looking at that what do you call it? The image there from the video. It's actually showing two verticals with two horizontals. Obviously, he's going to argue against it, but that's exactly what I was talking about.
Yeah, that's I've already been through that. Yeah, the Jeff, the main surveyor's done a video about that. There's no geometry to back it up, is what I've been saying to you.
Yeah. Do you know what a theodolite is? Bev?
Yeah, of course I do. I thought you were asking Mr. Sensible.
Oh, I know. No, Mr. Sensible knows exactly what a theodolite is.
I bet he doesn't.
I certainly do. I don't know how to use one, but I certainly know what one is.
Okay. You know what they're used for?
Yeah, for surveyors use them, right?
To
do their job.
Do you know what happens when, say, you got two theodolites right next together, right? they're going to be basically firing on the same plane as one another. Okay.
What, next to each other?
I've set them 5 kilometers apart.
Have you?
And they do not
are
fire on the same plane.
Are you a surveyor?
And they do not fire on the same plane when they're 5 kilometers
Mr.
apart.
Glass Monster, are you a surveyor?
Yes.
Okay, and you've set up 2 theodolites at a 5 kilometer
5,000 meters. 5,000 meters.
apart.
Yeah.
Okay.
That's about 2.5, about 3 miles.
Okay, and what is your finding? What were you doing this for?
I proved it to myself that there is a curve. They demonstrated it.
Right, so from 2 theodolites, that's 2 points, measurements, you are going to do what? Are you doing reciprocal?
Do you realize how they work?
Are you doing reciprocal measurements?
You're raising your volume, I'll lower your volume.
Sorry?
When you raise your volume, I'll drop it.
Glass.
I don't know what you're talking about.
Whoa. Glass. Bev didn't raise his voice, mate. He didn't.
It got louder. That's all.
Did I? I didn't.
No, well, I didn't notice it.
Okay. I just cut it down so it's the same as everybody's. That's all.
And I'll say that I've just had a 3-hour live stream with Bev, and we kept things calm throughout. There was no shouting or anything like that. So
yeah,
I can vouch for Bev.
Yeah, I just don't want to shout.
You're a class act, Mr. Sensible. Good job.
Well, thank you, Cleary. Yeah. I thought it was a class discussion.
Cleary. How you doing, Cleary?
It sure was. Hey, what's going on?
Yeah, I've been using the old Theodos for a while, playing around with them.
Okay, so when you were doing these 2 measurements, were they reciprocal?
Aiming back forth at each other?
Yeah.
Unfortunately, yes, they were.
Okay, so you're going from 2 points to another point, right? So that's just 2 points. And you say, because you did that, curvature, you got curve, did you?
You set the 2 machines absolutely level with, respect to their location.
Horizontal.
You set the second machine, level, plumb, vertical.
No.
And then you set the second
No, sorry, vertical isn't level. They're 2 different things. I can't get you to
absolutely
finish.
Vertical means that no matter what direction I point that in, it's going to be pointing at the same level, no matter which way I rotate it.
No, at 90,
in fact,
if you setting it at vertical, then 90
vertical.
Degrees would be horizontal. What are you saying level would be?
Don't argue with how I set stuff up.
I'm just trying to understand what you mean is level, please.
And I'm not going to use the word level because I know it's a K word for you guys when you're arguing with people about flat Earth.
No, you're using a theodolite,
So I am not going to really primarily use the word level or flat. So I set the thing up so that the center of axis form was absolutely vertical. And then I set the second one up, my friend set it up, so that it was absolutely vertical. And when we fired the beams back and forth between us, the beams did not hit square on. There was an angle of attack. And we both got the same angle of attack.
Angle of attack? That's a Nathan Oakley term, isn't it?
In other words, basically, you could say the beam was firing.
Isn't that a Nathan Oakley?
The beam was pointing up, kind of at a gentle angle.
The beam was pointing
up at a gentle angle with respect to his. Now, if the thing was flat, I should have pretty much shot my beam into his lens, and he should have pretty much shot his beam into my lens.
Sorry, one up. What do you mean by up? Like, you seem to be all over the place, mate.
You know what it means.
No, I don't know what it means. You just said you've got 2 theodolites and you are pointing them at each other, but one of them's up. What do you mean by that?
They both fired high.
Why? Why are you aiming high?
The machines were perfectly at a 90 degree.
Horizontal then, right?
With respect to their plane of location. And when you fire them back towards one another from 5 kilometers apart, the curve becomes plane.
I don't understand. The curve becomes plane.
And when you set them 2.5 kilometers apart,
a plane's a 2 dimension. surface.
And when you set them 2.5 miles or 2.5 kilometers apart, it cuts that angle in half.
I'm not so sure you're a real surveyor, mate.
And when you set them 1,250 meters apart, it cuts the angle in half again.
Yeah, due to sinking, optical effects.
Yeah.
That's all you're seeing.
Is that you, Jeff?
And we did this at 10 different times during the day.
Is that you, Jeff?
Sorry, is who, Jeff?
Glass Monster.
Oh, I don't know Glass's real name.
Oh, it's not Jeff.
No. Okay.
Glass Monster's always appeared in here as Glass Monster and has his own Discord called Glass Monster.
Right.
I don't know anything about a Jeff.
It's a surveyor though. That's handy. A new surveyor on the scene.
I have no idea.
I'd like to have a talk with you, Glass, at some point if you'd be up for that. Talk about surveying methods and how you measure the curve.
Just the talk will only last until you start contradicting.
Sorry?
And that, and you trying to say, I'm just going to use an example, a famous example of people mixing up flat and level, for example, which are totally different things.
I've never used flat.
Okay, good.
Level is horizontal is my claim, right?
Glass, what do you call a technique where you aim one theodolite at another at a great distance like that? What is that?
Well, it's definitely a way of finding out the angle.
Is that what the instrument's designed for?
No, that's not what it's designed for. It's designed to help you actually make a flat surface. If you wish, you can use them for transiting. You can use them for many things if you know how to do it. You can do the same thing with a laser level. You can use the flat stuff out too if you actually are skilled with it. And I'm not talking about using a laser over miles either. That's stupid. I'm talking over just a couple 100 feet. You can use it.
You've had some type of training with the instrument or what?
Yeah, back in 2000.
What, did you get a certification?
Yeah. I haven't been doing transit work for years.
So
I've been into diesel mechanic work for the last few years.
Yeah, so you basically are just using the instrument like you would a super zoom camera, and you're thinking that you're drop because you don't understand the limitations of the instrument. That's cool, no problem.
I can guarantee there's drop.
Yeah, whatever.
Are you a flat earther?
You can guarantee there's drop of the water level.
Three-dimensional.
Oh yeah, Clear is a flat earther.
I'm a three-dimensional.
Be a leveler. Come and join us, Cleary.
The one that said that, just say something one more time. The one that said he was a flat earther.
Who? Sorry?
Dog.
Oh, is that who it was?
Saying something one more time. In a very bad Britney Spears impression. Hello, everyone. Bev, what you were saying in the stream about using an auto level. I've never actually used one. I could probably describe how to design one, but not actually design it.
Wow.
You were saying you would look through a device which levels itself, as in sets itself perpendicular to what is vertically up and down where you are.
Yeah, horizontal.
And mark points at 25 and 50 meters in each direction.
Yeah.
Right. That will give you, I mean, assuming we're not looking at daft amounts of refraction, that will give you horizontal from where you are.
Yeah. It's called double rodding.
You can extend that over whatever distance you like, really, within the limitations of a device, which is going to be some tiny fraction of a degree. But you would use that, planting sticks in the ground and measuring between them, you would use that for laying out a house, wouldn't you? Or an apartment building or a leisure centre.
You use that for differential levelling.
The tool isn't designed for precision work over extreme distances.
It's 1 millimeter for a 1 kilometer double run. Is that not exact enough for you?
A single place, from a single location at 50 meters.
Yeah, and all the way back again for over a kilometer, and to a millimeter.
Yeah, if you're doing it again and again over a kilometer, you are moving the device.
Yeah.
And then what you're going to get is a series of 100-meter legs, each of which is level at its center.
Yeah, horizontal.
Whether
yes.
Earth is flat, concave, convex, spherical,
horizontal,
radius 1,000 kilometers or radius 10,000 kilometers or radius 100,000 kilometers.
That tool will always establish a horizontal line.
It will establish a horizontal where it is.
Yes.
Never used
and then when you move it, there will be another horizontal. Yes.
But it's not establishing.
That's what the tool is. That's what the tool does.
Why not use a piece of gear that can actually measure for kilometers instead of...
You say surveyors can't survey elevation? You can't survey accurately?
You can't keep that horizontal?
We are talking about surveying for different purposes here. If you're surveying from a single spot over a distance of 100 meters, we're talking about like 0.2 millimeters of difference. If you build a leisure center or an apartment building 100 meters by 100 meters and 100 meters high, the far corner of it...
That doesn't help us, but let's say you overlap...
The far corner of it, surveyed from this corner, is going to be different by a level of accuracy that you do not expect from builders. Plasterers do not work
wouldn't matter if it was out 10 inches.
So you can measure things and assume it's locally flat, and it won't make enough difference to matter to a plumber. I mean, you can bend copper pipes. How do you think they install taps?
You understand everything you're saying is a presupposition about something you've never done.
How would you
know installed plumbing? I bend copper pipes all the time.
Horizontal leveling, not plumbing. Horizontal leveling.
A building is small. A spot as small as he's saying, if you're out several inches over a spot that size, it's no big deal.
If you're moving your device and you're leveling a 100-meter strip and then another 100-meter strip and another 100-meter strip over a long distance, that's a different project. That is probably something like a water channel. Now, they have these in Madeira. They've had them for centuries, and they're actually a pretty good idea because they are zero electricity cost. You can cut a channel along a hillside, build aqueducts, drill tunnels, and take water at a steady 1 in 100 slope. And the difference it makes, that you're only surveying it once every 100 meters, is negligible to that. Because if it's a 1 in 99 slope or a 1 in 101 slope, it's still going to run nicely. Your water flow isn't going to get messed up by the slight difference that it makes. So that's another surveying job that is not the same as the surveying job for the building and is based on local level. It's based on level, not on horizontal.
Yes.
You don't care what angle the water flow is at one end of this channel. Like if we're diverting a river from, I can't remember if it's in Oregon or in Washington State, there is actually a river that is high enough to divert south this way to take out the Obispo fire that was burning a couple of years ago. You don't care at the river end of it, we are cutting into the river, what angle this is in Southern California. When you're in Southern California, you don't care what angle the far end of the channel is. What you care about is whether this bit of the channel is running.
Correct.
So that is a surveying method that is not going to distinguish between flat and curved because it doesn't need to. It doesn't give a shit. It is local level.
You can't get accurate enough to measure curvature?
Oh, you can, but
how?
The method being described isn't meant to, and it doesn't need to.
Right.
If you want to
wait a minute, why do you have a local level if it's not horizontal?
Locally,
my kitchen table is horizontal.
This spot where you set up this thing, like the water in the bath, level and horizontal are, wait for it,
the same thing.
Same thing within the limits of your ability to measure them, because
so
the difference.
You're a local flat earther, then, right?
Nanometers.
Yeah. You're a local flat earther.
Yeah. My kitchen table will not
be indistinguishable from flat.
Yeah. My kitchen table will not be level with respect to, say, Mr. Sensible's kitchen table.
And you can prove that? You've measured that somehow, or you just presuppose?
Yeah, we can. It's really easy.
Then do it.
Yep.
You take measurements of azimuth and elevation angle from the table to a set of stars at a particular time.
Stars.
And Sensible can do the exact same thing.
Table. There's only one of each star, and each star is only in one place.
Yeah.
And Sensible does the same thing at his table.
Yeah, why don't you measure the shape of the Earth and not look up at stars?
They've done that millions of times.
Who is they?
You want another way to do it?
Name
I got another way to do it. See, if you want to distinguish between, measure the radius, distinguish between completely flat or a 1,000,000 kilometer radius or 100,000 kilometer radius or 10,000 kilometers or 6,000.
Measuring radius are we on to now?
How do you measure the radius?
Yeah, that's good.
Find a couple of hills that are the same elevation above sea level at the summit.
Elevation? What do you mean by elevation?
Oh my God.
What do you mean about elevation? Come on.
Survey map.
Yeah.
You know those little curvy orange lines they put around the hills?
The contour lines?
Yeah, the ones that are all the same elevation above sea level.
Yeah, like a horizontal slice.
Yep.
Level.
He knows what elevation is. He just exposed it right there. He's just playing
horizontal
words.
Slice, right?
Class, I think you need to learn.
Locally indistinguishable from horizontal on small hills, but very different over something.
But that's what a contour line is. It's the same with. They all have the same vertical.
You do know what elevation is. So you're just bullshitting to interrupt me to stop me from talking.
It's a horizontal slice.
It's a horizontal slice, dude.
No, it's level, not horizontal. To
no,
distinguish that,
dude.
Stop interrupting and fucking listen. Answer the question.
Oh no,
you've
gone into the F-bomb now.
To distinguish between flat and curved, you need to measure over a great enough distance.
Tell us which geometry you're using.
Horizontal and level.
Tell us which geometry you're using in order to define this.
Actual geometry, not fucking fairies bouncing around inside your skull and Del's
Euclidean geometry, then.
Fuck up. Listen to the answer to your own fucking question. You find two hills with the same summit elevation. You go to the top of each hill. You measure the angle between horizontal and eye line of sight to the summit of the other hill from each hill.
Oh wow, that should be really accurate with
that's cool.
Compression, refraction, and everything else. Yeah.
Can we add another hill in?
Radius, not an actual
Can we
radius,
add another hill in?
But I can tell you what it won't give you. It won't give you a flat.
Flat? Why do you guys keep saying flat?
Yeah, they love it.
Because you're a flat earther, Cleary.
Love it.
I wish. Yeah, it'd be paper thin, wouldn't it? That'd be great.
They're all leaving, aren't they, Cleary?
Yeah, they are.
They're all going away.
Yeah, because of the dark holes.
They're all getting triggered by geometry.
Well, to be fair to Dog, he was trying to answer the question when you asked how would you measure the Earth's curve, and he was trying to explain about these two hills, and various people did keep interrupting him.
He kept saying that the same elevation, and then he wouldn't explain what he means by elevation. And then he went to go and talk about
perfectly
contour lines.
Fucking well what we mean by elevation.
Contour lines, you said. You did that yourself. You said contour lines.
No, I didn't. I said those squiggly orange lines they draw around hills. You said contour lines.
Well, what do you call them then?
Oh, I call them contour lines. I was just
there you
tricking
go,
you into admitting that you know perfectly well what contour lines is.
Yeah, well, they are horizontal.
Is and how to find two hills that are the same elevation.
Horizontal slices.
Rag.
They are horizontal slices.
No, they're not. They're level.
Using which geometry, please? I mean, I've been asking
geometry.
you. Yes. Well, what? Do you know what actual geometry is?
Used by mathematicians who know what they're talking about and are capable of using geometry.
Yeah, there's a book.
You rely on someone else to tell you what's going on?
There are a lot of books. There are books by Terry Pratchett.
Mm-hmm.
There are books by J.R.R. Tolkien. There are James Bond books. There are books by that guy who keeps writing about the head of the CIA going out to South American countries to shoot drug dealers. Jack Ryan or something is the character's name.
Are any of them?
There are books about chemistry. There are even Bibles.
Are any of them axiomatic systems?
Ooh, you found a word to quote. Well done. You know who else found a word to quote? Nobody cares.
No.
Some idiot found a word to quote. Somebody's postulate about light taking a path that is stationary with respect to adjacent paths, and he couldn't explain what it meant. He quoted it about 20 times, but couldn't explain it. I bet you don't know. Can't explain what axiomatic means either.
That was nice, eh?
Gotcha.
No, I don't think you have.
Yeah, good
I
luck
don't.
with
I
that,
don't
though.
think you even know what you're talking about. But it's nice. Geometry, like you don't even know what it is, do you? You think it's just about shapes and stuff.
It is.
Hey, dog, are
Yeah,
you a
geometry is
pure,
about shapes. If you really want to get back into the etymology of the word, geometry, measuring the earth.
Yes.
There you go.
Thank you.
Geometry. Thank you. Dog, why do you seem defensive? Like you have something to defend? Aren't you seeking the truth of the reality, or you got some presupposition you're trying to defend?
No, I was just explaining something. You two clowns are the ones being all defensive, trying to defend your pathetic ideas by not letting anybody explain what's wrong with them.
Okay, so
Come out and make an observation, then talk about it. You're just talking from a standpoint of, you're arguing from ignorance.
it almost sounds like you don't think we'll be able to measure a deviance from horizontal, like the drop of the water level, like Jesse Kozlowski says.
Guys, do you know what I got here? Do you know what I got here? Do you know what I got? I've literally got a nice bag of popcorn. Carry on.
I think you've already missed the popcorn. Actually, maybe you've opened it just in time, because these guys just said I've never been out and measured it for myself, and that I've said it can't be measured. After I posted into general chat the video thumbnail from my video of me going out and measuring it.
Well, there it is. Let's all go home now.
What was that? Measuring it? Where's that?
Bev, we know you're stupid, but not even anybody here thinks your memory is that crap. You know perfectly well what I'm talking about.
I'm saying where? Which one am I looking at?
You're just playing
No,
dumb.
you asked what's it.
Imagine being confused by a pronoun.
Yeah.
Oh, here we go.
Flurf tactic. Play dumb.
So say that again. Which is the one I'm meant to be looking at, please? That where you've measured it.
Don't you know how to use Discord?
No?
You talking to me?
I'm talking to the person that's just said that I should look at the bit that you've just told me to look at, and I'm asking you, which is the bit I should be looking at, please?
Just go back to the first time he posted it.
I don't know who's...
You're misquoting me again. I
Who
didn't
is
say
it?
you should look at it. I just said I just posted the thumbnail for it.
Okay. Brilliant. So nothing then.
That's it.
We're not doing anything with that. Okay.
Is that image with Black Hambleton? Is that what you're talking about?
Yep, that's the one.
Where is Black Hambleton?
It's 11:50. Oh, sorry.
North Yorkshire
Where it
Moors.
is, I don't know, but the image is at 11:54 p.m. General chat.
Okay.
It's on the North Yorkshire Moors. It's a fairly boring sort of hilltop in the northwest corner. So as viewed from southern parts of the Yorkshire Dales, it is the leftmost part of the North Yorkshire Moors. You have the view out over, like Middlesbrough, out over the North Sea to the left, and then Black Hambleton, and then the rest of the moors.
Yeah.
How high were you when you took that?
There's angular size reduction, and there's perspective. There's.
Those are just words. You don't even know what they mean.
Yeah, right.
They're just nonsense words.
Because you don't understand. You call it word salad, right? I don't understand what you're talking about.
No, I understand. You're just using them wrong.
Well,
judging by what it says in the thumbnail that I've posted, which is also now there twice because I posted the video as well, I was at 400 meters above sea level.
Yeah, but when it says sea level, what do you mean by level? And because you've got eye level there as well.
Imagine being
Horizontal.
confused by the word level.
Yeah, is that a straight line or a curved line? The eye level that you're at there. What does that
Straight
mean?
line from his position.
Oh, it's a straight line, that one. That level means a straight line.
No, it's a projection.
What about the sea level? Does that mean a straight line?
No.
No. Okay, so
Does
you've
voltage
got
level
level
what about
meaning
level?
two different things there, haven't you? One's straight
words
and
have
one's
multiple
not
meanings.
straight. That's the
It's amazing how
definition
when you
of
go
the
to
difference between the two, right? A straight line is
amazing when
defined
you go
as
to the
not being.
dictionary And you find multiple definitions of words. It's weird. Are you just finding this out now?
What's up, Negator?
Yeah, yeah.
Well, look, I've already said I've got no experience of surveying and that's the first time I've seen that image. To me, this will be interesting. Don't say anything until I've finished, Dog, because I don't know. What that implies to me is you are stood 400 meters above, or your eye line is 400 meters above sea level. That is the eye level is the horizontal from your position. That other black, whatever it is also 400 meters above sea level, and yet it's below your eye level, showing drop. Is that what we're talking about?
That is indeed.
Okay. Whoa, bam.
So, what's the difference between the sea level and your eye level then? Is it that 400 meters?
And you're drawing your that eye level is your horizontal plane that's perpendicular to your vertical.
Okay, so that eye level, right,
That's
is different than the other level by that distance. So that the difference between level and level is whatever you can see in that picture.
No, the two peaks where you are and the other one are both 400 meters above sea level. They are
that's
level
that
with
level,
each other.
yeah, sea level.
Yeah, 400 meters above. So
Okay.
they are level with each other.
Yeah.
Your eye level, looking out on your horizontal plane, your perpendicular
All right,
to
so
your
the eye
vertical,
level.
once you project it
Okay,
out,
yeah, I get
is above the other 400
Is it
because of
is
earth
it the
drop.
salt water or just the water that makes level change from being a curve?
If you're going to start bringing salt in it, we're bringing Anthony Riley.
No, look, you've
Oh,
got
God, don't do that.
one
The
there. You've got two measurements there, right? Both of them are
I'm not about to carry
400
dozen boiled
meters
eggs
above
up
sea
hill.
level.
Just
Yes,
to take a silly
Right,
photograph.
but one of them you've labelled eye level,
Yeah.
With or without a
right?
butcher's
But
coat.
that's higher than the other one that's
Exactly.
at sea level, at the same height above sea level. So
Yes.
the sea level at that other place is different than that when your eye level gets to that other place. That there is a difference between the level of your eye and the sea over that distance.
No, your eye is the same. Well, assuming you know, allowing for the height of your body. So forget that. Your eye level would be the same on either peak above sea level, but dropping a plumb, taking the perpendicular to it, and your horizontal. That's you're looking out across that horizontal plane.
Oh, so your eye
if
level
it was
is horizontal.
If it was a flat Earth, you would expect your eye level to match up with that other peak, which is also 400 meters above sea level.
Okay,
Unfortunately, it doesn't because that's horizontal,
Yeah.
which is not
Well, your
the same
eye
as
level is horizontal. That's what you're saying, right? So perhaps when I'm using level,
He's intentionally
I'm
not
talking about
understanding it.
that level, right? The one that is horizontal. Now, the one that you're imagining further off in the distance is something that you call perspective compression into the distance. Yes, it is.
No, it isn't, Bev.
Because if it was a flat Earth, looking from peak at 400 to a peak at 400, it would look small, but it would still be at your eye level.
Well, look,
Why does it
flat
appear
Earth.
below your eye level if it's flat?
It's elevation, topographic changes. The Earth. There's very few places that the Earth is flat.
Yeah, but they're both 400. You could have them both as 0 if you like.
Is that picture just taken with a camera?
No, actually, that picture was created by me using watercolor paints, then converting the paints in my head into hex codes and manually inputting them on the keyboard. Of course, it was taken with a camera.
A theodolite or an auto level, so there would be no crosshairs to say what actual horizontal is in that picture.
Looked at the picture yet?
I'm just looking at it on the thing. Yeah.
No crosshairs, but a couple of angry rabbits.
You need to get a
vertical thing with there's kind of something in the foreground that's pretty much vertical, and it's kind of got a level on it. Did you notice that part?
No, I'm just looking at the picture.
I didn't think you'd notice that part.
Yeah. Sensible. Yeah. Why does it seem to me that now quote me if I'm wrong, he seems, and I'm talking to Sensible, he seems to want to deny or refuses to accept when people give him correct information.
To be fair, Clear is right. You should talk to Bev, Glass. If you're saying that
flat earthers in general. Okay, I'll use all flat earthers seem to do this.
We are not flat earthers.
Don't count me in then. Are you talking about other people, or do you want to address us as a people? Are you talking to me?
Because you seem to really know the actual ins and outs of the actual information that is being given. You just seem to want to refuse to accept it. It's what it's really, really clearly looking like. You know the information, you just do not want to accept it. And I suspect it's because it goes against what you want to believe.
I'm using Euclidean geometry and practical facts that I can prove.
Yeah. It's like people in religions. Everyone else's religion is wrong, regardless of the religion.
Yeah. It's going to take a little while for you guys to learn a few things. It may take a series of conversations for you guys to understand geometry. And
globes are not a religion. Globes are an absolute scientific fact.
Based on what?
Wow, that's well defended.
Even I use it.
Based on what?
And you can predict so much stuff on it.
Based on what?
Reality.
What? Tell me your one
reality based on reality.
Best proof. Go.
Reality.
Best proof. Come on.
That was it. Reality.
Reality. Thank you.
Reality is Euclidean. How about that? Vertical is perpendicular to horizontal.
You can have your
a water level is a tool to establish a horizontal plane of reference.
Do you think the sun sets behind a geometric sphere edge?
When the sun sets, it's because the Earth is rotating and puts it out of our line of sight. Simple as that.
How far away is that geometric sphere edge for a 6-foot observer at sea level?
Not this again.
Come on. Go with me. I'll carry you down this road.
I'm not going to go through this stupid argument with the 50th flat earther.
Do you want to have
yes, you are.
Horizon?
It's the exact same. You guys got a playbook. I know you do. Over there on the 24/7 flat Earth.
I've never been there before in my life.
They all have
24/7, dude. Who the hell do you think you're playing with?
I got one for you.
How far away?
How far away is the geometric horizon for a 7-foot observer? You haven't memorized that one, have you? And you don't know how to work it out.
I don't know. I could look it up. What is it? What does Mick West tell you it is?
Geometric horizon. 3.5
inches. What about a guy
or something?
that's 4'8"?
Probably a little bit like 2.5.
Is that on your model? You want us to predict what your model says for the calculations?
What would be the distance for Michael Jordan? You know what I mean?
You guys know where I'm going to lead you, and you don't want to go there. That's okay.
I don't go to fiction.
Memorized, but you can look
in the
it up.
fact.
Don't work it out.
Go there. You don't have to defend the globe. The globe doesn't like you anyway.
The globe's a fact. I don't have to defend the reality. Reality speaks for itself.
The government tells you what to believe, and you believe it, right?
I hate the government. And I know I'm a Glober.
Then why do you believe what they tell you?
It's funny.
I don't believe in the government. I believe what I see with my own equipment. So
hey, I was watching the ISS yesterday,
well,
and it disappeared.
Isn't the ISS a governmental owned object?
See that?
Yeah, must be. Yeah.
Or is that NASA a governmental agency?
Do you think the government could trick you into believing the ISS is something in space when it's really not?
Use a telescope at the right time of day.
I use my.
I've got a video
I filmed
of
it with my flipping phone. Was that Cleary? I filmed it with my phone. Sorry, I'm losing my voice.
Well, I just use a telescope because that's what I have.
I got a pretty good transit.
Geronism used the prediction. Geronism used the prediction software and took photograph of it or film of it transiting the sun, and it showed the shape of it. Yes.
Interesting.
Exactly.
Yeah, the angular size of that would be a little bit smaller. Plus, it's going 3 times faster than a bullet. So yeah, good luck. I don't know what you're looking at. You know, I think they have holograms that maybe they could simulate that.
I know what I was looking at. It was the ISS.
If a person had holograms,
it was Jaren, right?
Technology, that'd make one heck of a movie theater.
If it was going,
do you guys trust Jaren?
Cleary, if it's going twice the speed of a bullet past your head, then no, you wouldn't be able to take a photograph of it. But remember, it's hundreds of miles away, so it's not going to whiz past you like that. But even so, it crossed the disk of the sun in a second or less than that.
So you trust Jaren with that?
Inside the ISS, why are there no cameras on the outside?
I'll tell you what, Jaren didn't trust Jaren because he took a photo of it with his own equipment when it was predicted to pass, and then he didn't believe what he saw.
I saw him do it live, man. I was there. It was about 2.5 years ago.
Clary,
why would you mount a camera outside?
Clary, give this a thought. Give this simple test a thought. Take a friend, get a friend, get him to, where you can see a road for pretty near a mile away, and tell him to drive by at 100 miles an hour, and then stand right next to the edge of the road and get him to drive by you again at exactly the same speed. You tell me
when we get a ticket, are you going to pay for it?
You tell me which one seems faster.
When we get a ticket, are you going to pay for it?
I was
pick any random speed.
Cheaper and safer.
Say 40 kilometers an hour then. Instead,
look at trees beside the track and look at distant mountains.
Appear slower from a distance, just like the ISS.
Yeah. Okay, I'll be right back. I'll go do that now.
Yeah, sure you will.
Yeah, anyway, we have a lot of things to teach you guys. You should come around over to Emma UK server and
Glass. It's no good telling him to do anything using a road. The government builds roads. Don't expect him to trust anything the government tells him, do you?
Hey, he shouldn't be using the internet because probably 3/4 of the internet was put together by the government.
Oh no! Oh no!
Government pays contractors to build roads.
Most of the satellites in space have at least some connection to government equipment. He shouldn't be using
satellites that don't.
So he shouldn't be using any long distance communications. He shouldn't be watching satellite TV. He shouldn't be watching satellite radio.
They don't understand that science. It seems like.
Cleary, have a look at a website like Heavens Above or any of the other prediction ones. Go out and look at the ISS or other satellite pass overhead, and it will appear and disappear in the place where it says at the time it says.
I used an
optical telescope to do that, one with no electronics.
I used to install commercial satellite dishes. They receive a signal, right? Guess what? The same signal that Marconi bounced off the ionosphere is the same signal you guys think they're penetrating through that ionosphere now. Interesting, isn't it?
Well, I think that bouncing. I'm not fully into radio. There are people who belong to my channel who are, but it does depend on weather conditions and so on. But all I'm saying is go out with your eyes, not even binoculars, and watch the fucking thing go over.
Oh, dude, the angular size of that object would be way smaller. Could you see a football field from 250 miles away? I couldn't.
Mr. Sensible, can you answer this? If something else transits the sun, can you say that the satellite is actually doing that? Is the ISS the only one that can transit the sun and you can actually take evidence of that? Or are all other satellites not able to do that, transit the sun and see that?
I have no idea about other satellites. I've never even thought about it. I see no reason why not. However, the ISS is particularly large and bright, and also there's a lot of interest in it.
Right,
I have never looked into it. I'm saying I don't know either way. Okay, I think it's a fairest thing to say.
Let's get back down to the ground.
So there's no technology besides looking at the ISS
and
maybe.
a football field not have in common? What does the ISS and a football field not have in common?
They don't play football on the ISS?
No,
Eggs in salt
extremely
water.
Reflective object.
Football fields on
Grass
the
is not
ground.
reflective.
Oh,
Those ones in the water.
Right.
All the shiny stuff.
So there's no space being taken up by the other satellites. There's no mass given off.
Most satellites are pretty small.
There are a heck of a lot of satellites that you can see, especially if you're in like northern Britain, northern Canada, Scandinavia, probably northern parts of Japan.
Yeah, but none of them actually transit the sun, so you can see them.
I'm
Except for
sure
the ISS.
they do, but a lot of them are.
Well, let's see where they are.
Hey, dog, can you see my trash can right here?
They're uninhabited.
Well, the thing is, Cleary, you won't even go out and look at the ISS, and now you're talking about observations that would be. You're talking about observations of smaller objects transiting the sun when you need a lot more accuracy, and you'll need equipment to see them. Whereas you can go out there, you can look at that website. It will tell you, put in your location. It will tell you when the ISS is going over, what time, how bright it will be, when it will start, how high it's going to cross the sky, and when it will finish. And until you go and do that, and then show that it's wrong, you're pissing in the wind, really, mate.
Yeah,
I did it twice tonight.
Until they just got their new bathroom up there. I guess they've been pissing in the wind this whole time. But thank God they're finally getting a new bathroom.
Good avoidance.
Well, I've just found my video. I'm going to try.
I didn't avoid anything. What do you want me to do? Here I am.
I saw the ISS twice tonight. That was pretty good on prediction.
No, you saw something that looked like the ISS that doesn't actually look like it. And they've proven that.
Hey,
yeah, it was a government craft powered by lizards.
Maybe it was a demon orb flying through the sky.
Indeed, who knows?
Well, that's where the names comes from.
Hey, Cleary, not only can I see your trash can from here, I've just posted a link to your trash can in general chat.
Oh my God, man, that's amazing. Welcome to the horizontal plane.
Yeah, and it says flat Earth on it.
Well, I don't own that trash can. Flat Earth trash can that he does.
It's your trash, though.
Well, I've just dropped in general chat a link on my video where I filmed the ISS using an ordinary Samsung Galaxy phone. It was predicted time before, and I showed the prediction, and I showed because it was going to be a good pass, and it was going to pass vertically between the Moon and Venus. So some brilliant markers, and it appeared exactly where it should. And that video was put out in March.
There are a lot
versus the Samsung Galaxy S9.
A lot of other satellites that you can observe from
Absolutely.
near polar latitudes. I was listing northern ones, of course, southern New Zealand, anywhere near Patagonia, Tasmania, possibly Cape Town, sort of southern Africa. If you're out just after sunset, just before sunrise, or all night near midsummer, you can see satellites gleaming in the sunlight because the sun is shining high above the pole and actually getting as far as Scotland and lighting them up there.
How does a geostationary satellite stay in orbit when it's not in orbit?
It is in orbit.
It's not moving anywhere.
It is. It's stationary relative to the surface of the Earth, but the Earth is rotating. The geostationary satellite is orbiting the Earth with the same rotation period as the Earth's rotation.
Huh. So
and it also has to be about 22,000 miles up, if I recall.
It all works in miles. Radius of 42,126 kilometers.
Wow, that'd be tiny, wouldn't it?
Yeah.
There.
You need a pretty good telescope to see geostationary. But the low Earth orbiters that are in near polar orbits, they're going over north and south poles once every couple of hours, you can see them gleaming in the sun at night. Yeah.
Did anyone see Starlink when that went up?
Oh, yeah.
That was
sweeps of dots making a right mess of the sky.
Yeah, that was a shame, but initially it was quite interesting.
Where you guys seeing all this, on the Sci-Fi Channel? Or?
That's quite a shot you took there, Sensible. I'm watching your video. Holy cow. You did that with a phone? Damn.
Yeah. Let's look back down at the Earth's surface. Let's measure that, shall we? Let's do that together.
Space is scary, I suppose.
Why? It's just lights in the sky, buddy. That's all.
Yeah.
I'm impressed, Sensible, with that phone of yours.
I like my orbs in the sky.
Yeah, they're pretty lights. I like pretty Christmas lights too.
I heard somebody make a
We should talk about rockets and moan about it hasn't got anything to push off, because that's always a funny one.
Oh my god, I love bottle rocket. I love ICBM. It's great. Yeah, fun to watch.
Rockets don't work in space. There's nothing to push off. Yeah.
Except for the exhaust that comes out of the end of them.
Is Gambino still in here, or is he gone? Oh, he's just in the chat. He's nice, isn't he? Gambino says the surface of a sphere is 3 dimensions. What do you reckon to that?
Well, Bev, I did see that picture of the football that you posted, and actually, this is a change of subject. Going back to what we were saying, if that top is the North Pole and you followed the line of the cut towards us, towards the front left, that's your first leg. You turn 90 degrees left around the equator.
See, can you see
and
the
then 90 degrees north?
underneath?
That's what I was talking about.
Yeah,
okay?
but see the picture underneath, though?
Which picture underneath?
Of the football.
I can only see one. Oh, right, yes. Oh, right, yeah, I was looking at the yellow one. I didn't see the white one.
Oh, right. The one above is the surface of the sphere. But that cutout shows you that the 90 degrees is between the plane surfaces. Right? So, in order to have, like what I was saying earlier, in order to have a geometry, your geometry has to define everything. And an angle is defined by the inclination of 2 straight lines or planes to one another.
Have you just been cutting up footballs and taping footballs tonight, or you just happen to have these?
No, this is what I use in order to explain how screwed you guys are with the geometry that you imagine.
Because where this came from was someone talking about flights of aircraft, and there was a challenge that a flat earther put, that you couldn't travel in one direction, turn 90 degrees, travel for a distance, turn 90 degrees, and go back to where you started. And I think it was Wolfie showed flight paths that did exactly that.
But
and there is it.
Can't,
and then the guy didn't pay up.
Yeah, the thing is, you can't though. That thing there proves that you need those 2 straight lines in order to measure the angle. That you can't measure it on a curve.
Yeah, earlier, Mr. Sensible, you said that's just a wedge cut out of a sphere. That's exactly what it is.
Yeah,
a
quarter. It's an eighth, isn't it? It's an eighth of a sphere.
Yeah, I saw the yellow football. I hadn't even seen the white one, so I was just thought, following the actual cut lines, that's the path I was describing. Then the white ball above with the blue tape is showing again the path I was describing. That was just something we talked about.
It's been cut out. It's been put in there.
Oh yes, I understand that.
I lift it out in order to show that you need those straight lines in order to do it. See, because if you're talking about the surface of a sphere, then
we travel over.
Well,
the
that's
surface.
A different geometry, isn't it?
But that's what we are talking about. If you were a North Pole and you decided to fly, you
let's
would fly
go
those
to that
paths.
geometry then, right? That geometry that you're talking about, spherical geometry, which is a non-Euclidean geometry, not even a true geometry, just a spherical geometry. So the spherical geometry is the geometry of the 2-dimensional surface of a sphere. So,
Mr. Sensible, I hope you're not drinking a shot every time this man says geometry.
So you understand 2-dimensional surface
yes, but
of a sphere does not go inside. So you do not have the definition of an angle within spherical geometry.
Right. If
The
you're
rocket-powered goalposts work in a vacuum.
Bev, using your white football there, you're parked in an aeroplane at the North Pole. You follow one of those. When you reach the equator, you will turn 90 degrees. You follow that for that distance, a quarter of the way round, which is what I said. You turn 90 degrees. You're then headed north, and you get back to your start point. That's all I was saying.
Mm-hmm.
You've got 3 legs. You have a shape with 3 legs, and 2 of the angles are 90 degrees. That's all I was saying.
Yeah, I know. I've been saying all along that you need 2 straight lines for an angle. So for a triangle, that's 3 angles. And an angle is the an inclination in between a straight line and a plane, or a straight line and a plane, right?
Well, you have 3 angles, and you have 3 straight lines there.
They're internal angles from the wedge you cut out. That's your 90.
I'm not even sure what you're trying to say, because
that's right. When you cut that wedge out, that's where the 90-degree angle is.
Well, you've got a 90-degree turn as you reach the equator.
But you're talking about something you've never done. You're saying, if I live on a ball, if I do this,
So you're saying you can make a triangle with 3 90-degree angles.
I never said that. I said you have a shape, and you said, what, a triangle? I said, well, I'm not sure what shape you would call it, because if you try to flatten that out, I'm not sure how it would appear. But what you've got is a journey of 3 legs with 3 angles, 2 of which are 90 degrees, and they are.
Oh, so when you're saying when you draw that thing on the surface of a sphere and imagine that it's a 90-degree angle,
that
then
is a 90-degree angle.
It's not, because it's on the surface of a sphere. It's a 90-degree angle when you cut it out and use the internal flat planes that you've got there.
You drive to the end of your road, if it's a T-junction, and you turn left, you turn 90 degrees. That's just the same as there when you reach the equator.
Okay. But you can't do that in reality, can you?
What do you mean? You can turn at the end of your road. You could
but you can't make a triangle with 3 90-degree angles. It's impossible.
For the second time, I did not say 3 90-degree angles. I said with 2 90-degree angles.
2.
Well, you can't make a triangle with 2 90-degree angles either.
Okay, look at that yellow football picture, right? You've got the first path coming from the top through the black segment. It reaches the equator. What is that angle that you would turn left to follow around the equator? If you go due south and then at the equator you turn and follow the equator, what angle is that?
You're talking about a ball. You're not talking about reality.
We live on a frickin' ball.
Then go do it on the road.
That's what I just said. You could do that on the road. But if you fly from wherever you live now, if you got on an aircraft and flew due south until you hit the equator and then you turn left and follow the equator, what angle do you think you've just turned?
What equator?
Oh, for God's sake. There's no point in talking to you.
I've actually drawn this out before. I just looked. I've got it. I think it was a guy called Carlo that was doing this. See, 2 90-degree angles there. Those lines can't meet because that's they're parallel. Is that what they called with 2 90-degree angles on a straight line?
You've got them there.
Yeah.
Hey, Bev.
Yeah.
Excuse me, Bev. Unrelated to anything. I've invited you to a server that is a calm, quiet server that we can talk about shapes of the earth and stuff as well. It's Smooth's Fight Club. Is not as it sounds. Okay?
Smooth.
But if you want to come... Yeah.
No, Smooth has already been over to MEUK.
Huh?
Yeah, he should come to MEUK. Very pleasant place.
But you can come visit the server with us if you like to.
Oh, you're talking about a different server. I was like, what are you talking about?
Smooth's Fight Club, it's called.
Mm-hmm.
I just
Smooth.
invited you, Bev.
Yeah.
Yeah, we talked.
You've invited me. Is that for a particular reason?
Yeah, I'm one of the 2 mods on that server, and me and him agreed to allow you to come onto the server. That it's okay. You seem to be a good guy.
Okay. You're also invited over to Emmy UK. Thank you very much.
Okay.
Yeah, let's continue to.
Hey, it's a loving.
That's great.
Yeah.
We
guys,
have entered a new,
just to let you know, I'm off in 5 minutes, guys. Okay.
Yeah. My server is a little bit different, so I tend not to bring flat earthers on my server because there's a lot of people that don't like.
So, like, can I go back to that picture? Because you said that 2 90-degree angles there. That would make, like I say, 2 parallel lines. That's basically the what you guys tend to call the parallel postulate, isn't it?
You have followed
within
one
Euclidean geometry. So that would dictate parallel lines. So you cannot be using Euclidean geometry. That's the point we get to, right? The geometry that defines that.
It's a sphere, not a flat plane.
Okay, so you're not. Okay, so you are not using Euclidean geometry.
No, they're using Euclidean geometry, just not all of the postulates.
Okay, so which ones are you using and which ones aren't you using?
I think it's all bar the 5th postulate, as far as I remember.
All right, it's okay. A straight line in between 2 points, and 2 straight lines can't enclose a space. All right angles are equal. All of them.
You can't.
It was the one about the parallel lines.
Surfaces to enclose a space. Lines can only enclose an area.
Pardon?
You can't enclose a space with lines. You have to use surfaces to enclose a space. Lines can only enclose an area.
You need another D.
2 straight lines cannot enclose a space.
Yeah. Well, no shit. 5 million straight lines can't enclose a space.
Like 3 straight lines can. You call it a triangle.
No, a triangle is an area, not a space.
No, I'm not so sure about that.
You're thinking 2D, Bev. He's talking 3D.
Well, 2 straight lines cannot enclose a space. Where do you think that would... could you manage to get that, or would that still hold true? Or do you think in some point you could get that to hold true? Because, I mean, that is one of the axioms. Euclidean geometry. Is that one of the ones you're keeping gently, or you want to get rid of that one too?
I'll keep that one, although I wouldn't define it as enclosing a space. On a 2-dimensional plane it would, obviously, because you would be talking about the surface of a sphere, but that would be academic because you're talking about a surface, so you're talking about area, not a space.
Oh, so what's space then? How are you going to differentiate?
Well, it's got an extra dimension. It's got a dimension that you're not included.
What, 2 straight lines?
Well, yeah, but you could have 2 straight lines on a sphere. They would enclose an area, but they wouldn't enclose a space.
Sorry, you could have 2 straight lines on a sphere?
Yeah, 2 great circle roots on a sphere would...
No, that's curved. The surface of a sphere is a 3-dimensional surface. It curves in 3 dimensions at every point.
Straight 3-dimensional.
Straight? How can it be straight?
A straight line on a curved surface?
Absolutely. What do you think the equator is?
It's not a straight line.
Of course it is. You would follow going neither north nor south. You are headed in a dead straight line.
Yeah. You're looking at it from one direction. You don't realize that it's not a straight line.
If it's on the surface of a sphere, it's a curved line, right?
In the third dimension, yes.
Well, that's what. Do you not? Where do you live?
I honestly don't think you're getting this, do you? Look at those blue lines you put on that ball.
Do you want
each of those three
two-dimensional surface of a sphere then? Right? Is that what you're having?
Sorry?
Are you having a two-dimensional surface of a sphere?
Well, what else is a surface?
What? It's three-dimensional of a sphere.
Oh, so what's the height of a surface? Look at those blue lines on your white ball. Each of those three blue lines is straight. It doesn't go left or right. It goes from point A to point B. Then it has a turn to go to the next point.
No. The three dimensions is length, breadth, and depth.
So thickness. What's the depth of a line then? What's the depth of an equator?
Sorry, a line is one-dimensional, isn't it? Within Euclidean geometry. I mean, you have a different geometry, right? What's your definition of a line? Length without breadth, I think, is a line is length without breadth. Euclidean definition number 2.
Hey,
If you want.
Like you said, Mr. Sensible, you take a 100-mile long steel straight line pipe and you put it on your sphere, it doesn't match up.
No, that's right. It's a tangent, isn't it?
So it's not straight then. One of them's not straight.
Well, it's still...
It depends on what your argument is. If you're saying straight is the shortest distance between 2 points.
Yes, that's an interesting way of putting it, yeah.
The shortest distance between 2 points on a surface of a sphere is in a straight line.
A straight line
will be curved.
A straight line is that which lies evenly between its extreme points. How about that?
Well, it would do on the surface of the sphere, though, wouldn't it?
What?
No. A line doesn't have extreme points. That's a line segment.
No, a line has extreme points. Of course it has. The extremities of a line are points.
No,
that's number 3.
Line goes off to infinity in both directions.
Said no, then.
Segments are inside the line.
Different geometry, then. Please give us your definition, then, of this from your geometry. Because I'm giving you Euclidean elements.
Put the definition of a line in 2 dimensions to avoid confusing you in general chat and a question about it. Let's see you try to answer the question.
Sorry, what was that? Say that again. I missed that.
You asked for a definition of a line. I have put a definition of a line in general chat for you and asked a question about it.
That's a definition of a line.
Well, it's a description of a line.
Right, well, Euclidean elements, because it's an axiomatic system, starts off with a point is that of which has no parts or which has no magnitude. Number 2, a line is length without breadth. Number 3, the extremities of a line are points. 4, a straight line is that which lies evenly between its extreme points.
I think we can all agree on that.
That sounds pretty good, right?
Yep.
You want to define it some other way for a straight line, right? And if you have that, have you ever tried to define a straight line for yourself? You know, like an actual definition. Can you imagine now, like if somebody asked you to define a straight line, how would you do it?
The amusing part is that the description you just gave doesn't rule out a spherical surface at all. How you can go?
If you want to have a go, just have a quick
another on a great circle.
Have a quick definition of trying to define a straight line.
Great circle. Is that a curve?
It's on the surface of a sphere.
Not if you're looking straight down at it. It's not.
Do you want
straight down? So you haven't. Yeah, you're looking at it from one direction. You pretend like it's straight. Yeah.
Would you know how to define a curve?
Have you looked at the line definition I posted in general chat?
Would you know how to define a curve?
Have you looked at the line definition I posted in general chat and tried to ask
that's not
a question about
definition?
Photograph? Come on, brother.
Mr. Sensible, would you invite the dude I just sent you the name of to your to your server, seeing I can't seem to invite people to your server? The links don't work.
There's links in the description of all the videos and the stream tonight.
Are we getting WS in? Are we getting all the crew in now?
But,
can we have a definition of a curve? Because I'll give you, right, in order to define a curve, you need a radius.
Yeah, that's what they need on a globe.
Which is a straight line. A radius is a straight line. But you can't define...
defined in general chat without a radius.
You can't define a straight line. It's elemental. That is the basis of all measurements and things you come from. A straight line is intrinsic. Doesn't need defining, really. It's known, and it's known as not having any curvature.
Well, why are you avoiding the question in general chat about the line definition I posted there several minutes ago?
The photograph?
No, the question about a line definition that I posted.
Y equals 3 to the power x plus 7. That definition, right?
Yeah, that one. There's a question right underneath that definition.
There's a line. So the y-axis, would that be a straight line? Would you call that vertical? That y. And then the x-axis, would you call that horizontal? And would you ever have a horizontal intersecting another horizontal in that graph system that you've got there? Or is it just when you imagine it to be on the surface that when you actually use it in practical terms? Within maths, it doesn't happen. But whenever you use it in reality, then of course they have to intersect, right? That's what happens, isn't it, in reality? Because you guys, that's where you guys work, isn't it? Best. Most of you have practical experience of horizontals and levels in reality. Working tools. You know, you've done that sort of stuff. So you've used geometry in a practical sense, and you get your proofs from it. Or you
Good evening, Smooth.
Just imagine.
Yo.
Hey, Smooth.
Yeah.
You've got big backup. He's not going to be as big a help, I think, as you imagine.
Hello, Smooth. Welcome to the server. Have fun. Play nice, guys. I'm going to be off in just a minute, okay? It's been a blast. I've enjoyed it, okay?
Okay. Yeah, cheers.
Cheers.
All right, man.
Cool.
We'll do this again sometime.
Yeah, we will do, Bev. We will do.
Have a look into the geometry. Let's get a good one going.
I'm going to keep you up to date on my contraption on how it's coming.
Yeah, and anything you tell me, Glass, or show me with pictures or whatever, will be treated in confidence, okay? So I won't spoil it. Won't spoil anything.
Yeah, someday maybe I'll show it to you on webcam.
Okay.
You know, in a private voice chat.
Yeah, no worries.
But not.
No, that's fine. That's fine. Right, all the best, guys.
All right.
Take care. Bye.
Take care.
Night, Mr. Sensible.
Good night. Good night.
Already on, dude.
Hi, Smooth.
No.
Yeah, Smooth's one of my friends. He's pretty good. He's calm like me.
Yeah. Yeah, we've
calmer than me actually.
I think I've talked to Bev before.
We've met. Yeah.
Yeah, like a day or two ago.
Yeah.
Were you the one who told me about the level argument?
Yeah, see,
Oh,
Glass, he'd never even heard of it before this level. He said it was amazing, an amazing argument, because he couldn't rebut it at all.
Amazing.
People like to put words in people's mouths.
He said.
No, he actually said that.
You want to hear the soundbite?
Yeah.
Go for it. Citation needed.
So you guys are getting to know the arguments now.
Yeah.
Good.
Yeah, it's great.
Mr. Sensible's first time, and a lot of this stuff. Smooth second time now, it looks like.
Yeah.
Yeah, dog's coming along for sure. Yeah, great.
Here, boy.
This geometry thing's great. It's good to see people learning logical principles.
Fantastic.
Yeah, I won the maths prize twice already. I got nothing to learn from you.
Right.
Really? are you making up geometry like Fight the Flat Earth, or are you just using his geometry? Is he leading the way, or is it like a group effort?
Smooth. If you want to try to teach this guy anything about maths, first you're going to have to teach him how to actually pronounce the equation in general chat. Then you might be here for about 8 hours teaching him how to answer the question right underneath it. Well, half an hour of teaching, an hour and a half of repeating yourself, and 6 hours of waiting for him to stop interrupting. Good luck with that.
Yeah, dog. That's why you never learn, because you just are so defensive. You feel threatened somehow. It's okay.
He's getting stuck on a straight line and a curve. Like
His
it's just
world's
a differentiation.
It's a safe place.
Yeah.
It's okay.
Clary, you ain't even a threat to a cheese sandwich. Never mind to me.
Clary likes sandwiches, I think, though.
Yeah, I don't like
eats
carbs. Really.
Cheese.
Yeah. Yeah, the cheese is good.
You're not in the dairy.
No. Well, that's it. I guess his argument is something about cheese.
Yeah.
What is that cheese?
Did we get it sorted? This straight line and a curved line, because I think that we did actually make it right down to
talk
that.
about this. All right. I'm gonna get at some people who want to hear this argument. All right.
So, oh yeah, we're getting a team.
The gang.
Wow, it's pretty late, but I mean, I guess I'm
back up.
gonna have to be
I'll
staying
send you guys.
up
I'll
tomorrow,
send you guys an invite.
Right, so we're on to the surface of a sphere, and whether a line is straight or not. I'm guessing we need it to be. You guys need it to be a straight line, because you've got a geometry that you need it to be straight on, right? Gently, because you need to be able to have those postulates, right? And them early axioms, or you call them the axioms, don't you? You need to have them.
Well, yeah.
Oh,
we still use all geometric systems are axiomatic. No matter what you look at, it still has an axiom.
Yeah.
Right. So there's no point arguing which axiom you want to use. It just depends on what geometry you want to use, right?
Okay. So if you're defining your geometry as not Euclidean, then you should be able to show all of the axioms and definitions and whatnot for your geometry that isn't Euclidean, right? I mean, that's fair enough, right?
Yeah.
Cool. Sweet.
I can do that. What, you want some?
Well, yeah. Like if you're saying you've got a different geometry that defines things differently, can you show us that system, right? Because it should be an axiomatic system. That's what it is. It works through logically, and then you get to prove all of your statements that you've made earlier. That's what makes it a system, right?
Yeah, we've had this discussion before, though, Bev. Quite literally all sets of geometries, Euclidean through every type of geometry you want to try and use, it's all got an axiom. There is no geometry that doesn't have axioms as a precursory role to you using that geometry.
Okay. Well, when we say the one Euclidean geometry defines as a straight line as being a straight line, it lies evenly between its extreme points.
Right, but that doesn't preclude a great circle on a sphere from that definition.
Well, it would, because that would be like a diameter or something. Like if it goes from one side, lies evenly between its two extreme points. That's a line. Right,
yeah.
Not a circle.
Why not? It would lie evenly between any extremity that it would have, right?
No, because a circle's defined differently, isn't it? Within Euclidean
Straight line
geometry.
circle.
Yeah.
Show me a straight line circle.
It would just be a great circle route around a spherical object.
Drop an image for us, will you?
A coin is a circle.
Yeah,
Straight
is that a
line
straight
coin?
line?
Right.
Is it?
So if you turn a coin on its side and look at it, is it not straight?
You mean like take a horizontal slice through a ball?
If you want to look at it like that, but the
that's-
surface that you would be
That's
looking
not the
at would be
surface, is
straight.
it?
My vinyl records are all circles.
Oh my
Okay,
God.
but if you look at one of those from
straight line round the outside of it, is it?
okay, but let's say
The circumference
you
of
were
a
a little-
circle is a straight line. Have we got
Letters
any
in a
there?
hard drive
Is that
are
a
circles.
definition?
how does it not work with your definition of a straight line?
What?
I just thought of where you'd probably find something that would be a relatively straight surface. The platters in a hard drive would be probably
Are
pretty
you
darn
guys
flat.
are you guys joking now?
Of course we are. A circle may be described from any centre at any distance from that centre. That doesn't really
So the
say
way I
much
would
about
describe it,
straight line.
What do you
I
think,
would
Andy?
describe it as the shortest distance between 2 points.
You said scribe it?
But
You're gonna
if-
draw it?
Yeah. Describe a circle.
Dog. Would you agree that the platters in a hard drive are pretty darn flat?
A straight line is said to touch a circle when it meets the circle, and being produced does not cut it.
That's a tangent.
Straight lines are said to be equally distant from the centre of a circle when the perpendicular lines drawn to them from the centre are equal. Straight line on which the greater perpendicular
Right, so that would
suggest
suggest that the line
further
we
than the centre.
But that would
You guys,
suggest
like,
that the
talk
line
about
that
it
you
like a-
drew would be straight.
I'm trying to find out here where it says that the circumference of a circle is a straight line. Doesn't seem to have it.
Yeah, I've been looking for that for a while. I can't find that.
No, it's not.
Well,
in
it's
here.
been hilarious, but Bo's posted new videos. We'll have to watch that instead. Bye.
Oh, see, who was that?
Dog,
Who did we
dog.
miss
Dog.
there? Dog. Bye, dog. Oh, he wrote some more little equations out. Nice,
Yeah.
nice. He must feel safe with them. About you,
Yeah.
Glass? Do you feel all right with them equations? Can you hide behind them as being a straight line? Like, is that a good enough definition of a straight line for you to give you a chance that it's got a bit of curvature in it somewhere when you need it to?
Smooth Fight Club. He wants us to go there, it seems.
Yeah, I'm
I
going
didn't
to
get an
be
invite.
I'm going to be
I didn't
calling
get an
it
invite
tonight.
from Glass.
Who?
Glass didn't send me an invite to his server.
Yeah.
Glass only wants Bev.
Oh, right.
Jerry 7816 got an invite. Check
Oh,
your
wow.
text.
I feel special. Should I bring
I
a
directly sent you an invite.
Awesome.
Is this sort of a debate sort of thing, Glass? I mean, what is it over there?
It's a debate. It's calm. It's moderated. It's one-on-one, and it's
Okay,
no
so-
fighting and no yelling over each other.
What are we going to sort out a deal now, and we'll maybe come round
You
sometime
have
soon.
to talk. It's smooth servers. So the deals have to be done with smooth servers. I'm a moderator on there. Yes.
Oh, so you got no
Smooth
power then?
Owns it.
Okay.
Smooth
All
owns
right.
it. Smooth owns it.
Are
So
you
he's
not
still above me.
Are you not working for him then? You're not.
I'm helping him with the server, but
Okay, well,
he owns the server. So
You can tell Smooth then, because since he's already been
yourself.
over to
You know-
Emma
you
UK,
already-
well, you're his
you know.
mod. You're his mod.
You can text
But if he
him
wants,
yourself.
if he wants us to come over to his, he can come and ask us, since you can't do it, or he'll give you the power to be able to do it.
I already asked you
if he
to
wants
come.
to sort, yes,
I already asked you to come.
Yeah, but if you let me finish, if he sorts out what he wants us to talk about and all of that, since it's a debate thing, right? We don't just turn up. It has to be slightly structured, right?
Yeah, it is. It's a flat Earth globe debate, is what it would be.
Well, we are neither, so why would he want us there?
It still is just a debate.
Okay, so you like, but you like to debate different models, right?
It's a
we're not into that.
It's a commonplace.
We just do.
It's a commonplace.
We just do reality. We don't bother with models. We don't care what sort of a model you have.
But
it's just what you can
go over.
You can prove.
Just go over and have a chat with them.
Yeah, so cool.
You know, you don't like it, leave. But go over and have a chat.
Yeah, I appreciate you, Glass, man. You seemed a little uptight earlier, but you're cool now. That's cool.
Yeah.
It's always nice to meet new people too.
Oh God, I'm not new, man.
Well, you're relatively new to me.
Oh.
I wouldn't mind having a quiet one-on-one just conversation with you sometime, but we'll have to do it on
There must be loads of people, and how many people do you reckon that don't know this level argument? Is it new to all of you?
Well, I'm heading over there anyways now to Smooth Server. If you want to talk to me, you'll have to go there.
Okay.
Take care.
All right. See you later.
All right.
Thanks for the offer.
Always run.
Yeah, right.
To the shelter of their server.
That mine thing stumped them.
Yeah.
They all took off. They clearly got that wrong, so they took off.
Yeah. You did a great job, Bev. I know you're probably wiped out now, man.
Yeah.
Yeah.
Well, we're
pretty late.
still recording and still streaming. So, well, I mean, yeah, if it sounded like it was good.
Oh man, it's been great. You've been solid all day long. I don't know how many hours it's been now. What has it been?
Yeah.
4.5?
Yeah. Sweet. Right, I'm going to cut it off and go and get some kit then and get ready for tomorrow.
Yeah, that's cool. All right.
All right.
Cool.
See you later, guys.
See you.